Far beyond the noise of the modern world, in the quiet expanse of the cosmos, an ancient and unbreakable rhythm repeats itself. It is written in the slow turn of planets, the steady orbit of moons, and the silent dance of distant stars. This rhythm is not separate from us. It is the same quiet pulse that settles in your chest as you drift into sleep, a reminder that even in our most personal moments of rest, we are connected to the grand, silent machinery of the universe. Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. This is a journey into that connection. Not myth or speculation, but a look at the real, tangible cycles that shape both the world outside and the world within. Some of these cycles are vast, playing out over millions of years. Others are as immediate as the rising and setting of the sun. All of them stretch our idea of what it means to be in sync with the world. Welcome to the Sleepy Scientist. If this kind of calm exploration into the world around us helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether in a quiet room, a busy city, or somewhere in between, feel free to share where you're listening from. For many, sleep feels less like a natural rhythm and more like a struggle. It can be a source of frustration, nights spent staring at a ceiling, or mornings that arrive without any sense of rest. This feeling of being out of sync is not just a matter of comfort, it can have profound effects on our well-being. But our understanding of sleep often remains focused entirely inward, on the body and the brain alone. Perhaps the context for that struggle, and a quiet path toward resolving it, lies not just within us, but in the planetary cycles that have governed life for billions of years. Let's begin with the rhythm we live every day. Our Earth spins on its axis once every 24 hours, a precise and stable rotation that carves our experience into periods of light and darkness. This is the fundamental clock of our world, wound by gravity and momentum. It is the rhythm to which all life on this planet is, in some way, attuned. But it is only one rhythm among many. Other worlds move to different beats. Jupiter, a gas giant of immense scale, spins with such speed that its equator travels at over 45,000 kilometers per hour, completing a full rotation in less than 10 hours. Venus moves in the opposite direction, a slow, retrograde turn that takes 243 Earth days to complete. These are not random movements, they are stable, locked in cycles. Even Mercury, the closest planet to the Sun, follows a peculiar tempo. It rotates exactly 3 times for every 2 orbits it completes, a 3-to-2 resonance that is both stable and strange. These planetary rhythms are the background music of our solar system, a constant display of how order and repetition are fundamental forces in the universe. And then there is our own moon, locked in a perfect one-to-one dance with Earth, forever showing us the same face because gravity has bound its spin to its orbit. This principle of being pulled into sync, of resonance, is not limited to planets and moons alone. If we look outward, to the moons of Jupiter, we can see this dance play out in even greater detail. Io, Europa, and Ganymede orbit in a perfect 4:2-to-1 resonance, a gravitational symphony where for every 1 orbit of Ganymede, Europa completes 2, and Io completes 4. This is not chaos. It is a stable, self-correcting system, a set of ratios that brings harmony to what could otherwise be a disordered gravitational field. We see it even in distant solar systems, like TRAPPIST-1, where 7 rocky worlds circle their star in a chain of resonant orbits. Their gravitational pulls on one another ensuring the stability of the whole system. These cosmic rhythms are not just a curiosity. They offer a profound analogy for the rhythms within our own bodies. Just as planets are governed by the cycles of light and gravity, our own biology is tethered to the 24-hour rotation of the Earth. Deep in the brain, a small cluster of cells called the suprachiasmatic nucleus acts as our internal clock. It responds to the natural light-dark cycle, regulating the release of hormones, the fluctuation of body temperature, and the waves of brain activity that guide us towards sleep and waking. This internal timing, this biological resonance, is known as our circadian rhythm. It is a roughly 24-hour cycle that anticipates the needs of the day and the night. When the sun sets and light fades, our body begins to produce melatonin, a hormone that quietly signals it is time for rest. This process is, in a way, its own form of tidal locking. Just as the moon is locked into a 1-to-1 ratio with Earth's orbit, our internal biology is designed to lock into a 1-to-1 ratio with Earth's 24-hour day. It is a simple, elegant system, essential for our well-being. But what happens when we disrupt this rhythm? When we introduce artificial light late into the night, or when our schedules fall out of sync with the natural rising and setting of the sun, our internal clock can become confused. This desynchronization can lead to fatigue, insomnia, and a feeling of being perpetually adrift. Like a moon pulled from its natural resonance, our bodies struggle to find a stable pattern when we ignore the fundamental rhythm we evolved to follow. Light is the great regulator. Exposure to natural light during the day reinforces our circadian clock, sending a clear signal that it is time to be alert and active. As daylight fades, the absence of bright, blue spectrum light allows our biology to begin the gentle process of preparing for sleep. This is why creating an environment that respects this natural cycle can be so important, dimming lights in the evening, avoiding the bright screens of our devices, and allowing the body to listen to the ancient cues of day and night. Instead of thinking of Jupiter's fast rotation as a metaphor for insomnia, or the moon's lock as a sleep twin, we can simply see them as different expressions of a universal truth. Rhythm creates stability. The perfectly spaced orbits of Jupiter's moons and the chain of resonance in the TRAPPIST-1 system are beautiful examples of how predictable cycles allow complex systems to endure. In the same way, a consistent rhythm in our own lives provides an anchor for our biology. A disrupted, chaotic schedule, much like a non-resonant orbit, requires constant correction and expends energy, leaving the system fragile. So how can we better align with these natural patterns? The approach can be gentle and intuitive. Finding this rhythm can begin with small, consistent acts. Creating a steady pattern of sleep and waking, even on days of rest, helps anchor the body's internal clock. A relaxing routine before bed, one that does not involve bright screens, can serve as a signal, a kind of personal sunset that tells the body it is time to unwind. This could be reading, listening to quiet music, or simply sitting in a dimly lit room. The environment where we sleep also matters. A cool, dark, and quiet space removes the disruptions that can pull us out of our natural cycle. Paying attention to what we consume, and when, is another layer of this. Heavy meals, caffeine, or alcohol close to bedtime can interfere with the body's processes. And perhaps most simply, spending time in natural daylight helps to calibrate our internal clock with the world outside. Perhaps you might try one of these ideas tonight. If you feel so inclined, you could share your experiences in the comments below. As we conclude, it's worth taking a moment to reflect on this larger picture. The cosmos is not a cold, empty void filled with random events. It is a grand, interconnected system of cycles, a silent lullaby of repetition and return. The Earth's spin cradles your own sleep cycle. The orbits of planets demonstrate the stability that comes from rhythm. The constant, predictable patterns of the universe are a quiet reassurance that you are not alone in the dark. The connection between your sleep and the universe, then, is both profound and beautifully simple. By understanding the fundamental rhythm of our own planet, and seeing it reflected in the grander cycles of the cosmos, we can learn to align ourselves more closely with the natural world. So the next time you close your eyes and feel your breath slow, remember that you are part of a much larger dance, a cosmic ballet that has been unfolding for billions of years. Thank you for joining me on this journey. If you found this exploration helpful, consider liking the video and subscribing for more content like this. Why we sleep. The cosmic secret of nighttime. Every 24 hours, our planet turns, a slow and silent rotation that has governed life for billions of years. Long before animals, long before forests, life was already experimenting with this rhythm. And for all our complexity, we are still bound to it. But have you ever stopped to truly consider why? Why we surrender a third of our existence to unconsciousness, simply because our patch of Earth has turned away from the sun? The answer isn't just a matter of biology. It's a story written into the very physics of our solar system. It suggests our nightly sleep is not a chore, but the keeping of an ancient, cosmic pact. The cosmic connection. Imagine our world. A sphere of rock and water, spinning through the void. It rotates on a tilted axis of 23.5 degrees, a motion that gives us the reliable flip from day to night. As Earth spins west to east, your place on its surface is carried from sunlight into shadow. This cycle isn't an accident, it's a dance born from the chaotic formation of our solar system. For millions of years, this predictable shift between light and darkness became a fundamental metronome, and life, in all its strange forms, learned to sync to it. But what does this celestial mechanic truly mean for us? It means our biology isn't just our own. It's profoundly intertwined with the rhythm of our planet's movement through space. This cosmic clock has shaped our evolution, a quiet and constant pressure that has influenced everything from how we find food to how we dream. Light and darkness as biological signals. As life experimented, it developed internal clocks, what we now call circadian rhythms, to anticipate the 24-hour cycle. These biological clocks were a radical innovation, allowing organisms to prepare for the changing world instead of just reacting to it. The primary signal, the Zeitgeber, that sets these clocks is light. Deep within our brain is a tiny cluster of cells, the suprachiasmatic nucleus, or SCN. This is our master clock. It receives information directly from specialized cells in our eyes, which are particularly sensitive to blue light. When the sun sets and that light fades, the SCN signals the pineal gland to release melatonin. This is the chemical messenger of darkness. It lowers our body temperature and builds the pressure to sleep. When morning light returns, melatonin production is shut down, and cortisol levels rise, preparing the body for the activity of the day. For eons, this was a near-perfect system. But our modern world has introduced a complication. The artificial light from our screens and cities mimics the signal of daylight, confusing our ancient internal clocks. This mismatch reveals just how deeply our bodies are still wired for the natural rhythms of the Earth, a world that is slipping away from us. The deep evolutionary role of night. For our ancestors, night was not merely an absence of light, it was a different world with its own rules. In the beginning, one of the primary drivers for this retreat into inactivity may have been the sun itself. Early life needed to escape the intense ultraviolet radiation of unfiltered daylight, which could damage delicate cellular structures. Night became a sanctuary. Later, as more complex life emerged, the darkness offered a different kind of refuge, from predators that hunted by sight and a time to conserve precious energy when foraging was inefficient. This immense evolutionary pressure shaped our sleep. It wasn't just rest, it was a survival strategy. Over deep time, it gave rise to the architecture of sleep itself, particularly deep sleep, a state critical for cellular repair and the maintenance of our DNA. Our internal clocks are an echo of this long story. In fact, research into ancient cyanobacteria shows their clocks were once synchronized to an 18 or 20-hour cycle. A trace left in stone of a time when the Earth itself spun faster. Our own 24-hour rhythm is a modern adaptation, a reminder that we are part of a planetary system that is itself constantly, slowly, changing. The human brain and night. As our bodies evolved, so did our brains. The human brain, with its startling capacity for thought, became uniquely dependent on the nightly process of sleep. Different stages of sleep were refined to perform different functions. Slow wave, or deep sleep, became essential for physical restoration and for consolidating certain types of memory, locking in the lessons of the day. But another, stranger stage also emerged: REM sleep. This is when the brain becomes highly active, almost as if it's awake. It's a period of vivid dreaming, but its function is far from frivolous. REM sleep appears to be critical for processing emotions, for integrating complex information, and for creative problem-solving. It's a time when our minds can make connections, explore possibilities, and simulate solutions. This cognitive rehearsal wasn't a luxury, it was likely a key tool that allowed our species to adapt and thrive. The modern disconnect. Today, we live in a world that is profoundly out of sync with our evolved biology. The demands of our 24/7 societies, the constant glow of artificial light, the endless stream of information, it all creates a conflict with the ancient programming hardwired into our cells. Many of us now experience this as a chronic struggle with sleep. The blue light from our devices is particularly disruptive, sending a powerful, daytime signal to our brains long after the sun has set, suppressing the melatonin that should be preparing us for rest. We are living through a massive, uncontrolled experiment on our own biology, and the consequences are becoming clear in our struggles with fatigue, anxiety, and a host of other health issues. We are modern beings, but our bodies remain quietly strange, still listening for ancient signals that are being drowned out. The cosmic secret revealed. So, what is the cosmic secret of night? It's the realization that sleep isn't empty time. It is an active, elegant, and deeply evolved process that connects us to the fundamental rhythm of our planet's journey around its star. It is a biological echo of a cosmic dance. The next time you lie down to sleep, remember that you are not just shutting down. You are engaging in a ritual that is written into your DNA, a process that has been refined over eons of life on Earth. Your sleep is a gift, a way of keeping time with the universe. It is a quiet reminder that we are all creatures of this spinning planet, shaped by deep time, chance, and survival. Why artificial light is breaking your brain's natural clock. There is a clock inside your brain, smaller than a grain of rice, that has been keeping time for millions of years. For nearly all of that time, it worked in quiet harmony with the rising and setting of the sun. But in the last 100 years or so, we have introduced a new kind of light into the world, one that has slowly begun to confuse this ancient timekeeper. This is a journey into that clock. Not a clock on a wall, but a biological rhythm that connects every cell in your body to the turning of the earth. We will look at how the gentle light from our screens and homes can send signals our brains do not understand, leading to restless nights and tired mornings. And we will explore the quiet, simple ways we can help our bodies remember the ancient rhythm of day and night. If this kind of calm exploration into the world inside us helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether it is day or night, feel free to share where you're watching or listening from. The ancient clock and a modern problem. For almost all of human history, our lives were shaped by a simple, powerful pattern. The sun came up, and we were awake. The sun went down, and we began to rest. This was not just a routine, it was the metronome for our biology. Our bodies evolved over immense stretches of time to anticipate these daily changes, optimizing how we feel and function for the light of day and the quiet of night. Every part of you, from your liver to your muscles, contains its own small clock, all moving to the same 24-hour rhythm. This internal timekeeping system, our circadian rhythm, is a biological echo of our planet's rotation. It decides when we feel alert, when our metabolism is most active, and when our body begins its essential repair work. It is a system of quiet elegance, refined over millions of years to keep our inner world in sync with the world outside. Then, in a period of time so short it barely registers against the scale of evolution, everything changed. First came the soft glow of the incandescent bulb, then the hum of the fluorescent tube, and now, the bright screens of our phones and computers. We have, in effect, created a world of perpetual daylight. This new, constant light has been a quiet shock to our ancient biology. Our internal clocks evolved to trust light as the undeniable signal of daytime. Now, they are being sent a signal that is no longer true. When you look at a bright screen at 11 o'clock at night, your brain is not just seeing a picture. It is receiving a powerful biological message, a message that says, it is midday. Stay awake. The result of this confusion is not trivial. It is more than just feeling a little tired. This mismatch between our ancient wiring and our modern world is a kind of gentle, chronic stress. Many of us feel a persistent fatigue, a difficulty falling asleep even when we are exhausted, and a fogginess in the morning that is hard to shake. These are not personal failings. They are the predictable symptoms of a brain in quiet conflict with its environment. To understand how to resolve this conflict, we first have to understand the conductor of this internal orchestra, the master clock in the brain. The master conductor, the suprachiasmatic nucleus, SCN. Deep inside the brain, in a part of the hypothalamus just above where the optic nerves cross, sits a tiny cluster of about 20,000 neurons. It is smaller than a grain of rice, and it is called the suprachiasmatic nucleus, or SCN. This is the master conductor for your entire body. Imagine your body as an orchestra. The heart, the lungs, the liver. Each is an instrument with its own internal clock, its own sheet music telling it when to be active. But without a conductor, they would soon fall out of sync, creating noise instead of harmony. The SCN is that conductor. It does not play the music itself, but it sends out the signals that coordinate every other clock, ensuring your body works in quiet, life-sustaining harmony. For a long time, it was not clear whether these rhythms were truly internal or just a response to the sun. In 1729, a French astronomer named Jean-Jacques Dortus de Marin performed a simple experiment. He took a mimosa plant, which opens its leaves by day and closes them at night, and placed it in total darkness. He observed that the leaves continued their daily cycle, even without the sun. This was the first real evidence of an internal biological clock. But where was it? It took until the 1970s to find an answer. Through a series of careful experiments with hamsters, researchers found that the SCN was the source of this rhythm. When they removed the SCN, the animals lost their 24-hour cycles of sleep and activity entirely. Their internal timing became random. In an even more remarkable experiment, they transplanted an SCN from one hamster into another that had its SCN removed. Miraculously, the recipient's daily rhythms were restored. The SCN was the timekeeper. What makes the SCN so special is that its ability to keep time is built into its very cells. Each of the 20,000 neurons in the SCN is its own microscopic clock. When isolated in a dish, a single one of these cells will continue to pulse on a roughly 24-hour cycle. Together, they synchronize to create one unified, incredibly precise signal for the rest of the body. This is the biological embodiment of our planet's rotation, a clock that knows the music of the cosmos by heart. The problem is, we have started to light the stage at all the wrong times, and the conductor is getting confused. To understand that confusion, we have to look even closer at the molecular notes themselves. The clock's quiet rhythm, how it ticks. How can a small group of cells keep time so precisely? The answer is found in a gentle, repeating cycle inside each cell, a genetic feedback loop so fundamental that its discovery was awarded the Nobel Prize in 2017. Inside each of these clock cells, two proteins named clock and BMAL1 spend the day turning on other genes. The most important of these genes are called period, per, and cryptochrome, cry. As these genes are turned on, the cell begins to produce per and cry proteins. As the day goes on, these proteins slowly build up inside the cell. Then, as evening approaches, the concentration of per and cry proteins becomes high enough that they begin to pair up. This new protein complex is then able to travel back into the cell's nucleus. Once there, it acts as a brake, gently stopping clock and BMAL1 from making any more per and cry. The daytime process is turned off for the night. Throughout the night, the accumulated per and cry proteins are slowly cleared away. As their numbers fall, the brake on clock and BMAL1 is gradually released. By morning, the brake is lifted completely, and clock and BMAL1 are free to begin the cycle once more. This entire loop, this quiet molecular rhythm of activation and inhibition, takes approximately 24 hours. This process was pieced together over decades, starting with fruit flies in the 1970s. Researchers found flies with broken rhythms and traced the issue to a single gene, which they named period. Later, scientists including Jeffrey Hall, Michael Rosbash, and Michael W. Young slowly uncovered the other pieces of the puzzle, revealing the elegant mechanism that was ticking away inside. The most important part of this story is that the clock runs on its own. Like Demiron's plant in the dark, it does not need the outside world to tick. But a clock is only useful if it is set to the right time. To be effective, this ancient, self-winding watch needs to be synchronized every single day with the real world. For all of history, that synchronizing signal has been light. And to receive that signal, the body has a dedicated antenna. The cosmic antenna. Your eyes do more than see. Your eyes allow you to see the world, faces, colors, and the light of a sunset. But they have a second, quieter function that is just as vital. They act as a cosmic antenna, detecting light not for vision, but for timekeeping. For many years, scientists believed the only light-detecting cells in the retina were the rods and cones we use for sight. But this created a puzzle. People who were completely blind, with no functioning rods or cones, could often still synchronize their internal clocks to the day-night cycle. There had to be another pathway for light to enter the brain. The answer came in the early 2000s, with the discovery of a third kind of photoreceptor in the human eye. These are a small, special group of retinal ganglion cells, now known as iPRGCs. They are not involved in forming images. They act more like simple light meters, sensing the overall brightness and color of the light around you. These cells contain a unique photopigment called melanopsin. When light enters the eye, these melanopsin-containing cells send a signal down a dedicated neural path called the retinohypothalamic tract. This is a direct, quiet line from your retina straight to the master clock, the SCN. There is no processing by the visual parts of your brain. It is a hardwired connection from the outside world directly to the conductor of your internal orchestra. This is the physical link between your brain and the cosmos. Light travels 93 million miles from the sun, passes through our atmosphere, enters your eye, and a signal arrives at your master clock, telling it what time it is. Your brain believes this signal above all others. Crucially, the melanopsin in these cells has a peak sensitivity to a particular wavelength of light, a specific shade of blue around 480 nanometers. In nature, this kind of light is most abundant in the bright, overhead sun of midday. The light of sunrise and sunset, by contrast, is much richer in reds and oranges and contains far less of this specific blue. Our biology evolved to read these colors as timing cues. Bright blue light means daytime. The absence of it means night is approaching. For millions of years, this system was nearly perfect. The only source of bright, blue-rich light was the sun. But to understand how this system regulates sleep, we have to look at the chemical messenger this light switch controls. The signal of night, the role of melatonin. One of the SCN's most important jobs is to control the release of a hormone called melatonin from the pineal gland, a tiny structure deep in the center of the brain. Melatonin is often called the sleep hormone, but it is more accurate to think of it as the hormone of darkness. Its release does not force you to sleep. It is the official announcement to your brain and body that it is now nighttime, and the time for sleep is approaching. The relationship is simple. When the iPRGCs in your retina detect light, especially that potent blue light, they signal the SCN. The SCN, in turn, actively stops the pineal gland from releasing melatonin. This is why you feel alert during the day. As darkness falls and the light signal fades, this inhibition is released. The pineal gland begins to secrete melatonin. Its levels rise a few hours after sunset, peaking in the middle of the night, often between 2 and 4 a.m., and then fall as the first light of morning restarts the cycle. This nightly release of melatonin is the conductor's signal that it is time for the body to transition into its nighttime state. The clocks in your liver, your immune system, and your muscles all have melatonin receptors. When melatonin arrives, it synchronizes them, ensuring the entire body moves into a state of rest and repair together. This nightly melatonin signal governs a whole collection of restorative processes. It helps regulate your immune system, it manages inflammation, and it has antioxidant properties, helping to clean up cellular damage from the day. When the melatonin rhythm is suppressed or delayed, it is not just sleep that suffers. This entire cascade of essential nighttime maintenance is disrupted. Your body can remain in a daytime state when it should be in a nighttime repair state. And this brings us to the heart of our modern problem. Our biology is designed to release this important hormone only in darkness. But we have filled our nights with something that powerfully suppresses it: artificial light. The great disconnect: how artificial light confuses everything. Now, all the pieces come together. We have an ancient master clock in our brain, the SCN, which keeps time on its own. This clock is synchronized to the real world by special light-detecting cells in our eyes, which are most sensitive to blue light. That light signal, in turn, controls the release of melatonin, the hormone of darkness that tells our body when to rest. For millions of years, this was a perfect system. Then we invented the light bulb and the screen. The central problem is this: your SCN cannot tell the difference between the blue light from the midday sun and the blue light from your phone at midnight. To your ancient iPRGCs, light is light. And blue-rich light means daytime. Consider a typical modern evening. The sun sets. For our ancestors, this was the cue for melatonin to slowly begin its rise. But for us, this is often when the artificial lights turn on. We watch television. We scroll through our phones. Each of these devices is a source of blue light. A well-known study from Harvard researchers found that blue light was significantly more powerful at suppressing melatonin and shifting circadian rhythms than green light of comparable brightness. Research has also shown that even very dim light, barely more than a nightlight, can be enough to interfere with melatonin. So when you look at a screen late at night, you are sending a direct biological command to your brain to stop producing melatonin. You are telling the conductor that it is still the middle of the day. The memo to prepare for sleep is never sent. Your body remains in a daytime mode. Your heart rate stays elevated, and your body temperature does not drop as it should. Then, you turn off the lights and expect to fall asleep, but you often can't. You may feel wired and tired. This isn't a psychological issue, it's a biological one. You have spent the last few hours exposed to a powerful biological signal for wakefulness. This nightly delay in the melatonin signal is what drives social jet lag. During the week, our alarms may force us up at 7 a.m., even though our light habits told our body it was not ready to sleep until 1 a.m. Then on the weekend, we try to catch up by sleeping in. This constant shifting is like flying across time zones every few days, and it is a quiet, chronic stressor on the body. Our biology was designed to trust light, and we have filled our world with a counterfeit version that is confusing the system from the inside out. We have become disconnected from the fundamental rhythm of our planet. Reclaiming your rhythm, quiet ways to reconnect. Understanding the problem is the first step. Taking action is the second. The beauty of the circadian system is that it is designed to listen to signals. This means we have the power to change the signals we send it. Reconnecting with your natural rhythm does not require complicated protocols. It just requires a quiet respect for the millions of years of evolution that shaped you, and a little care in how you manage light. First, greet the morning sun. This is perhaps the most important thing you can do to set your internal clock. The goal is to get bright, natural light into your eyes soon after waking. That morning light sends a powerful start signal to your SCN. This helps you feel awake, and it also starts a timer for the release of melatonin that night. Aim for 10 to 30 minutes of sunlight within the first hour of waking. On a clear day, 10 minutes can be enough. On a cloudy day, you might need longer. You do not need to wear sunglasses for this. You can simply drink your coffee on a porch or stand by an open window. Second, create a digital sunset, asterisk. Just as important as getting light in the morning is avoiding it at night. In the 2 to 3 hours before bed, begin to gently reduce your light exposure. Dim the lights in your home. Bright overhead lighting is a signal for daytime. Instead, use warm-toned lamps. The color of the light matters. Blue and white light are for day. Red, orange, and yellow tones are for evening. This also applies to screens. Most modern devices have a night mode that shifts the screen color to warmer tones. Use it. Better still, try to put screens away completely for the last hour before bed. Third, soften the artificial world, asterisk. For times when you must be around bright screens or lights at night, blue light blocking glasses can be a useful tool. For evening use, glasses with amber or red lenses are most effective, as they block the wavelengths of light most disruptive to melatonin. Think of them as sunglasses for the modern, artificial world. They allow you to exist in your environment while protecting your ancient biology from confusing signals. Fourth, find true darkness. When it is time for sleep, your bedroom should be a sanctuary of darkness. Even small amounts of light can be detected by your circadian system. This means using blackout curtains to block streetlights and covering the small LED lights on electronic devices. Try not to fall asleep with a television on. If you get up in the middle of the night, use a dim, red-toned nightlight instead of a bright overhead light. The goal is to create an environment so dark it allows your body to enter a full, restorative night of rest without interruption. For millions of years, the rhythm of life was set by the sun. Our biology is a quiet symphony composed to that celestial metronome. Deep in our brains, a master clock learned to listen for the daily pulse of light, connecting our bodies to the turning of our planet. This connection is not a metaphor, it is a physical, genetic reality. In just the last century, we have built a world that challenges this rhythm. We have filled our nights with an artificial light that our biology was not designed to understand. The resulting fatigue and poor sleep are not signs of personal weakness, but a collective sign of a biology that has been pushed out of alignment. The question is not why we struggle to sleep. It is how we could have expected to fool a system perfected over such an immense stretch of time. But we do not need to fool it. We can choose to work with it. We can greet the morning sun, dim the lights as evening falls, and welcome the quiet, restorative power of darkness. By understanding the profound science of our internal clock, we can begin to gently resynchronize ourselves with the natural world. We can mend the connection that artificial light has confused and reclaim the health, energy, and rest that are our evolutionary birthright. Thank you for watching. What is one small change you might make to your light habits? Let me know in the comments below. Science says the moon secretly controls your sleep. Have you ever noticed that your sleep seems to take a nosedive around the full moon? You're not alone. Many people report feeling restless, tossing and turning without a clear reason. It's as if there's this strange energy in the air that keeps you up later and leaves you waking up feeling like you barely slept. For ages, this phenomenon was brushed off as mere folklore, a relic of ancient superstitions about werewolves and madness. It seems illogical, especially in our modern world, right? After all, you might live in a bustling city, surrounded by the constant glow of streetlights and screens, often going weeks without even glancing at the night sky. So how could a silent, distant rock, nearly 240,000 miles away, possibly reach into your bedroom and mess with your sleep? It sounds far-fetched, defying common sense. For a long time, the scientific community shared this skepticism. Anecdotes and old wives' tales don't count as data. Yet, the persistent feeling shared by millions around the globe refused to fade away. This curiosity sparked a handful of scientists to dig deeper. What they uncovered is not just reshaping our understanding of sleep but also revealing a profound connection to the cosmos that we thought we had left behind centuries ago. It turns out, the moon is subtly influencing your sleep, and it's doing so through an ancient biological link that's far more intricate than just its light. The evidence suggests that even if you never see the moon, your body still feels its pull. This isn't a tale of werewolves or mystical forces. This is a story grounded in hard data, featuring groundbreaking research published in some of the world's most respected scientific journals. It takes us from remote, unelectrified villages in Argentina to the bright, light-polluted streets of Seattle. Recent studies have confirmed a biological connection between the lunar cycle and the structure of human sleep. We're talking about measurable changes. People going to bed later, sleeping less, and, most importantly, experiencing a significant drop in the most restorative phase of sleep. And here's the kicker. Scientists have found that in the days leading up to a full moon, your deep sleep can be reduced by a staggering 30%. This isn't just about feeling a bit groggy. A 30% reduction in deep sleep is a serious physiological event that can affect your immune system, memory consolidation, and overall health. And it happens whether you're sleeping under a clear, moonlit sky or in a windowless room in the heart of a city. The story isn't just about what you see. It's about a hidden clock, an ancient rhythm embedded deep within your DNA, still marching to the beat of a lunar drum. So, how did science crack this code? What hidden forces, from moonlight to gravity, are pulling the strings of your sleep? The global mystery, it's not just in your head. For generations, the notion that the full moon disrupts sleep has been a common complaint, shared over morning coffee or among weary parents of restless kids. It's a piece of human experience so widespread that it's become a cultural touchstone. In a survey conducted in Switzerland, for instance, around 40% of respondents reported feeling the moon's effects on their sleep or directly blamed it for a bad night's rest. Yet, for just as long, the scientific community largely dismissed this idea. The prevailing theory was something called confirmation bias. The logic went like this: the full moon is a big, dramatic event steeped in cultural significance. We have a pre-existing belief, fueled by centuries of folklore, that strange things happen during a full moon. So, when you sleep poorly on a full moon night, you connect the dots in your mind. You think, the full moon must be the culprit. You remember those restless nights, but you conveniently forget all the other nights you struggled to sleep when the moon wasn't full, or the full moon nights when you actually slept just fine. Your brain, in its quest for patterns, reinforces a belief that isn't really there. This explanation made sense for a while, satisfying scientific skepticism. Many early studies looking for a link between lunar phases and human behavior came up empty, failing to find any consistent, statistically significant connection. They examined hospital admissions, crime rates, and emergency service calls, and the so-called lunar effect seemed to vanish under scrutiny. The case appeared closed. The moon's influence was all in our heads. But human experience is a stubborn thing. The feeling was too common, too consistent across cultures and geographies to be easily dismissed. This is where a fundamental shift in scientific thinking began to take shape. A new question emerged. What if we've been looking at this all wrong? What if the issue wasn't a psychological bias, but a biological rhythm we just didn't know how to measure yet? This led scientists into the fascinating field of chronobiology, the study of internal clocks. Most of us are familiar with the most famous of these clocks, the circadian rhythm. The term circadian comes from the Latin circadium, meaning about a day. This is our master 24-hour clock, the internal pacemaker located in a part of the brain called the suprachiasmatic nucleus, or SCN. It's what makes you feel sleepy at night and alert during the day, governing everything from body temperature to hormone release. This clock is endogenous, meaning it runs on its own, but it's synchronized, or entrained, to the 24-hour day by external cues, the most powerful of which is light. But what if humans had other, more ancient clocks? The natural world is full of them. Many marine animals, for instance, have biological rhythms tied to the tides. Crabs and corals have reproductive cycles perfectly synchronized with the lunar month. This kind of clock is called a circalunar rhythm, from circalunum, about a month. For a long time, it was assumed that humans, as land dwellers, had lost or never evolved such a clock. We were creatures of the sun, not the moon. The revolutionary idea was to propose that maybe we hadn't. Perhaps, buried deep within our genetic code, was a faint, ticking circalunar clock, a remnant from a much earlier time in our evolutionary history. A clock that our modern, electrified lives had largely drowned out, but not silenced completely. The challenge was proving it. To do that, scientists needed to design an experiment so clever that it could separate the psychological expectation of a full moon from a true, underlying biological signal. They needed to find a way to listen for the moon's whisper above the roar of modern life. And that's precisely what a groundbreaking international team of researchers set out to do. The groundbreaking study, Cracking the Code. The definitive proof that this was more than just folklore arrived in January 2021, with a landmark study published in the prestigious journal Science Advances. This wasn't just another small-scale observation, it was an ambitious and brilliantly designed experiment that provided the first truly robust evidence of the moon's influence, tackling the biggest scientific objection head-on: the impact of artificial light. Led by Professor Horacio de la Iglesia from the University of Washington, this international team of researchers posed a simple yet profound question. Is the lunar effect on sleep real? And if it is, does it persist even when people are removed from natural light cycles and immersed in the electrical glow of modern urban life? To answer this, they knew they couldn't just study one group of people. They needed to compare sleep patterns across a spectrum of human environments, from the most natural to the most artificial. This led them to design a perfect natural experiment, studying three distinct groups of people. The first group came from the Tobacom indigenous communities in rural Formosa, Argentina. They focused on a community with absolutely no access to electricity. This was the crucial baseline. These individuals lived lives dictated largely by the natural cycles of sun and moon, much like our ancestors did for millennia. Their evenings were lit only by fire and the celestial bodies above. Studying their sleep would provide a window into our species' ancestral state, before the invention of the light bulb changed everything. The second group was another Tobacom community, but this one had limited, or intermittent, access to electricity. They might have a single source of artificial light in their home, but their environment was still predominantly dark at night. This group served as a vital bridge, a midpoint between a pre-industrial and a fully electrified world. The third group was on the complete opposite end of the spectrum: 464 college students at the University of Washington in Seattle. This is a hyper-modern, post-industrial setting. These young adults lived in a major city of over 750,000 people, surrounded by a constant bath of artificial light from streetlights, buildings, and, of course, the ubiquitous glow of their smartphones, laptops, and televisions. If the moon's influence was simply about its light, then its effect should be completely erased here, washed out by the far brighter and more immediate sources of artificial illumination. To track sleep, the researchers didn't rely on diaries or self-reports, which can be subjective. Instead, they used science. Each of the 98 participants in the Argentinian communities and the 464 students in Seattle was equipped with a wrist-worn actigraph. This device is like a highly sophisticated fitness tracker that continuously monitors activity levels, allowing researchers to determine with incredible accuracy when a person falls asleep, when they wake up, and the duration of their rest over long periods. They collected data for 1 to 2 full lunar cycles for each participant, creating a rich and detailed dataset of sleep patterns. When the team analyzed the data, the results were stunning and unambiguous. They found a clear and powerful oscillation in sleep patterns that synchronized perfectly with the 29.5-day lunar cycle across all groups. The key finding was this: in the 3 to 5 days leading up to the night of the full moon, people consistently went to sleep later and slept for shorter periods. This was a surprise. The common assumption was that the effect would be strongest on the night of the full moon itself, when it's brightest. But the data showed the effect peaked before the main event. The numbers were significant. Across the cycle, total sleep duration varied by an average of 46 to 58 minutes. Bedtimes shifted dramatically, with people going to sleep anywhere from 30 to 80 minutes later on those pre-full moon nights compared to nights around the new moon. But the real bombshell, the finding that made the scientific community sit up and take notice, was that this pattern wasn't confined to the rural communities. The Seattle College students, despite living in a world of constant artificial light, showed the exact same fundamental oscillation. The effect was more muted, more subtle than in the communities without electricity, but it was undeniably there. Even in the heart of a modern city, their sleep was still dancing to the ancient rhythm of the moon. As Professor de la Iglesia stated, we see a clear lunar modulation of sleep, with sleep decreasing and a later onset of sleep in the days preceding a full moon. And although the effect is more robust in communities without access to electricity, the effect is present in communities with electricity, including undergraduates at the University of Washington. This study effectively dismantled the old arguments. It wasn't just confirmation bias, because the participants weren't necessarily aware of the lunar phase, and the data was objective. And it wasn't just about the visible brightness of the moon, because the effect persisted in a light-polluted city. The results strongly suggested that human sleep is synchronized with the moon, regardless of cultural background or level of urbanization. Something deeper was at play. The first suspect was, of course, the moon's light, but the story was clearly more complicated than anyone had imagined. The prime suspect? Is it all about the light? With the 2021 Science Advances study confirming that the lunar effect was real, the next logical question was, why? What is the biological mechanism that connects a celestial body to our sleep-wake cycle? The most obvious and intuitive answer has always been the moon's light. The researchers in the Argentina and Seattle study provided a compelling evolutionary explanation for this. The reason the sleep disruption peaks in the days before the full moon is all about timing. During this waxing gibbous phase, the moon is already very bright, and it rises in the late afternoon or early evening. This means that after the sun sets, the moon is high in the sky, providing a significant source of natural light during the first half of the night. For our pre-industrial ancestors, this wasn't a nuisance, it was a gift. This extended twilight was a valuable resource. It was a natural, celestial lamp that would have made it possible to hunt, gather food, travel, or engage in social activities for several hours after dusk. It makes perfect evolutionary sense that our bodies would have adapted to take advantage of this predictable period of evening light. The nights around the new moon, by contrast, are pitch black, making outdoor activity dangerous and difficult. So, our ancestors likely slept more during those dark nights and stayed active later during the bright ones. The biological pathway for this is well understood. Our primary 24-hour clock, the circadian rhythm, is synchronized to the environment by light. Specialized cells in our retinas detect the presence of light and send a signal directly to the suprachiasmatic nucleus, SCN, in the brain, our body's master timekeeper. When the SCN receives a light signal, particularly in the evening, it interprets it as daytime. This, in turn, sends a command to the pineal gland to delay or suppress the production of a crucial hormone, melatonin. Melatonin is often called the hormone of darkness. Its levels naturally rise in the evening as darkness falls, which is what makes us feel sleepy. It doesn't force you to sleep, but it opens the sleep gate, signaling to your body that it's time to wind down. By providing a blast of light in the evening, the waxing moon essentially tricks the brain into thinking the day is longer than it is. Melatonin production is pushed back, the sleep gate opens later, and you simply don't feel tired until later in the night. You go to bed later, and if you still have to wake up at a fixed time for work or school, you end up sleeping less. This perfectly explains the later bedtimes and shorter sleep durations seen in the study. But this brings us back to the central paradox. Why on earth would this affect a college student in Seattle? The light from their smartphone is orders of magnitude brighter than the full moon. The ambient light pollution in a city is so intense that it often washes the moon out of the sky entirely. Surely, any subtle effect of moonlight would be completely overridden. This is where the theory gets even more fascinating, moving beyond a simple, direct response to light and into the realm of an inbuilt, self-sustaining clock. Scientists propose two main possibilities. The first, simpler explanation is that even in a city, our bodies might be more sensitive to natural light than we realize. Perhaps the subconscious detection of increased ambient brightness, even if we don't consciously notice the moon, is enough to nudge our biological clock. But the second, more compelling theory is that we possess a true, endogenous circulunar clock. Think of it this way: for hundreds of thousands of years, our ancestors' sleep patterns were modulated by the lunar cycle, night after night, generation after generation. This constant, predictable 29.5-day rhythm of bright evenings followed by dark evenings may have become genetically encoded. The rhythm became entrained into our very biology. According to this hypothesis, the clock now runs on its own, independent of the external cue of seeing the moon. It's like an old grandfather clock that, once wound, will continue to tick at its own pace even if you cover its face. The moonlight was the original winder of the clock, the force that set the rhythm in the first place, but now the mechanism is internal. It anticipates the full moon. In the days leading up to it, it automatically begins to suppress melatonin and promote wakefulness, because for our entire evolutionary history, that's what it was supposed to do. Artificial light, as the 2021 study authors suggest, may simply emulate the ancestral effect of early night moonlight, further delaying our sleep on top of this underlying lunar rhythm. This beautifully explains why the Seattle students, despite being immersed in artificial light, still showed the same pattern. Their bodies weren't just reacting to the light outside their window that night. They were following a genetic script written tens of thousands of years ago. The deep sleep heist, the 30% robbery. While discovering that the moon affects when we go to sleep and for how long was a major breakthrough, another group of scientists had already uncovered something arguably even more profound. They found that the moon doesn't just shorten our sleep, it fundamentally changes its quality, robbing us of the most vital and restorative stage of rest. This is the story of the 30% deep sleep heist. The evidence for this came from a 2013 study published in the journal Current Biology, led by chronobiologist Christian Kajokin at the University of Basel in Switzerland. What makes this study so powerful and elegant is the incredible level of control the researchers had. They wanted to create an experiment that would completely eliminate any possible psychological bias or environmental cues. They didn't want their subjects to see the moon, know what phase it was in, or even have the asterisk idea of the moon in their heads. So, they devised a clever plan. They took 33 healthy volunteers and had them sleep in a highly controlled laboratory environment. These sleep labs had no windows. The rooms were completely isolated from all outside light and sound. The temperature and humidity were kept constant. The participants had no access to clocks or phones. They were completely cut off from any external cues about the time of day or, crucially, the phase of the moon. But here's the brilliant part. The researchers themselves were also in the dark, so to speak. The data was originally collected for a different experiment that had nothing to do with the moon. It was only years later that Kajokin and his team had the idea to go back and retrospectively analyze that old data to see if the lunar cycle had played a hidden role. This means that no one involved, not the participants, not the technicians running the study, not even the lead scientists at the time, was aware that the moon was a factor. This double-blind approach completely ruled out any possibility of confirmation bias. While the volunteers slept, the researchers monitored them with a battery of high-tech equipment. They used electroencephalography, or EEG, to measure brainwave activity, which allows scientists to precisely identify the different stages of sleep. They also measured hormone levels, including melatonin. Your brain bends time while you sleep. Have you ever woken from a full night of sleep and felt as if only a moment has passed? The alarm sounds, light is coming through the window, and 8 hours have somehow disappeared between yesterday and today. Or maybe you have had the other experience. A dream that felt like a lifetime, an entire story lived in just a few minutes, only to wake and find it is still the same day. This strange stretching and compressing of time is not a mistake in your perception. It is a quiet, fundamental part of what your brain does each night. While your body is still, your brain enters a different state of activity. It begins to perform tasks that are critical for your memory, your health, and your sense of self. And to do this, it seems to change the rules of time. This is a story about our relationship with time, and how the silent work happening inside our brains at night reflects some of the larger principles of the universe itself. We're going to explore how the brain contains a clock that synchronizes our bodies with the planet. We will look at the physical changes the brain undergoes, how it rewires and even cleans itself while we are unconscious. And we will ask a simple question. If our perception of time is so fluid, what does that say about time itself? The 8 hours you spend asleep are not lost. They are transformed. To understand how the brain can seem to alter time, we first need to look at its timekeeper. Deep inside the brain, in a region called the hypothalamus, is a cluster of about 20,000 neurons. This is the suprachiasmatic nucleus, or SCN. You can think of it as the master clock for the entire body. This is not a metaphor, it is a physical system that governs the rhythm of your life. This clock does not run on gears. It runs on light. When light enters your eyes, it does more than allow you to see. Special cells in the retina send a non-visual signal directly to the SCN. This signal synchronizes your internal world with the Earth's 24-hour day. The SCN then sends messages throughout your body, beginning a cascade of changes. It tells your body when to raise its temperature to help you wake, when to release cortisol for alertness, and, importantly, when to release melatonin to prepare you for sleep. Nearly every system in your body, from digestion to immune response, follows the rhythm set by the SCN. This is why jet lag feels so disorienting. Your internal clock is no longer in sync with the new light-dark cycle. But light is not the only signal. The SCN also responds to what scientists call Zeitgebers, a German word meaning time givers. The timing of meals, exercise, and social interaction all act as smaller cues that help to fine-tune this internal clock. This system evolved for a simple reason: to allow life to anticipate the rhythms of the planet. Our ancestors had the sun, the moon, and an internal clock that evolved in harmony with those cycles. Your body knows, on a deep biological level, that the world operates on a schedule, and it has prepared itself to function within that framework. So, the first layer of your brain's relationship with time is not psychological, it is astronomical. It is a physical synchronization between a tiny cluster of neurons and the spinning planet you live on. And when this master clock signals that night has arrived, the real transformation begins. It is time to turn the focus inward, to a world where the rules of time are about to be rewritten. When you fall asleep, your brain does not shut down. It simply shifts its focus. The busy, outward-facing tasks of the day are replaced by a set of internal maintenance processes. One of the most important jobs is memory consolidation. The things you learned today, a new fact, a new skill, the feeling of an experience, exist as fragile patterns of neural activity. To make them last, the brain has to physically change its own structure. This process is known as synaptic plasticity. During sleep, especially deep, slow-wave sleep, your brain revisits the neural pathways used during the day. It strengthens the important connections and weakens or prunes away the ones that are less critical. This idea is known as the synaptic homeostasis hypothesis. It suggests that during wakefulness, our brain is constantly forming new connections, becoming more and more complex. If this continued without a reset, the circuits could become saturated with noise, making it difficult to learn new things. Sleep is the process that scales down this synaptic strength, carving your experiences into the more permanent structure of your memory. This is why a night of sleep after studying can be so effective. You're giving the brain the time it needs to physically wire that new information into its network. But this nightly work does not stop at rewiring. The brain also has to remove waste. The simple act of thinking creates metabolic byproducts. One of these is a protein called beta amyloid, which is known for its association with Alzheimer's disease when it clumps together. Recent research has revealed how the brain cleans itself. During sleep, the space between your brain cells actually expands. This allows cerebrospinal fluid to pulse through the brain tissue, washing away the metabolic waste that accumulated during the day. This process, sometimes called brainwashing, is one of the most vital functions of sleep. Without it, toxins could build up and impair brain function over time. This is the physical reality of sleep. Your brain is actively changing. It is rewiring circuits to consolidate memories and flushing itself to clear out waste. It is a period of intense, constructive activity. It is not surprising, then, that our conscious experience of this time feels so strange. Our awareness is disconnected while the most important system we have performs its own essential repairs. If this kind of calm exploration into your own brain helps you unwind, consider liking the video and subscribing to the channel. The brain's nightly work of rewiring and cleaning is methodical and biological. But then there is the other side of sleep, the strange and unpredictable world of dreams. This is where our perception of time can truly seem to break apart. How can a short period of REM sleep contain a dream that feels as though it lasted for years? To understand this, we have to look at what happens to consciousness when we sleep. It does not simply turn off. It transforms. You are still conscious when you dream, just in a different way. Your awareness is no longer tied to the outside world through your senses. It is turned inward, exploring a landscape made of memory, emotion, and imagination. This gives us a clue as to why time behaves so strangely in dreams. Think of your waking brain as being bound by the linear flow of events. It records things as they happen, one second after another, constrained by the constant stream of information from the outside world. The dreaming brain, however, is not bound in the same way. It has access to the entire archive of your life's experiences, every memory, emotion, and piece of knowledge. During a dream, it is freed from the constraints of linear time. It can take a memory from childhood, a feeling from last week, and a hope for the future, and splice them together into a single narrative. It can show a decade in just a few seconds through a montage. It can slow down a single moment until it feels like an hour. Time in a dream is not a river, it is a canvas. Your brain is not measuring duration, it is building a story. A story's time is based on narrative moments, not the ticking of a clock. This is why you can feel as though you have lived a lifetime in a dream. Your brain presents you with key events, a meeting, a journey, the passage of years. It often skips the quiet, routine moments that fill a real life. It gives you the highlight reel, and your conscious experience fills in the gaps, creating the feeling that a vast amount of time has passed. This ability of our brain to manipulate time is a nightly reminder that our waking perception of a steady, linear flow might be more of a useful convention than a fundamental truth. And while it may sound like science fiction, scientists have noticed interesting similarities between the patterns inside our heads and the patterns of the universe itself. We must be careful here. This is not about claiming that cosmic forces are directly controlling your sleep. The science does not support that. Instead, this is about an observational similarity in the principles of organization that appear at both very small and very large scales. In one study, astrophysicists and neuroscientists compared the structure of the cosmic web, the large-scale arrangement of galaxies, with the structure of the neural network in the human brain. The results were surprising. They found that the two systems are remarkably alike, just on vastly different scales. Both the brain and the cosmos are organized into a network of nodes connected by filaments. In the universe, the nodes are clusters of galaxies and the filaments are the strands of matter connecting them. In the brain, the nodes are clusters of neurons and the filaments are the bundles of axons that wire them together. Again, this does not mean a brain is a tiny universe. It is an observational similarity, which the researchers suggest may point to common principles that govern how complex networks organize themselves. It seems nature, whether organizing galaxies or neurons, favors a certain kind of efficient, resilient structure. But there is a cosmic connection that is not just an analogy, it is literal. It is the story of where the atoms that make up your brain came from. The calcium that allows your neurons to fire and the oxygen that fuels them were not created on Earth. They were forged in the heart of a star that exploded billions of years ago. You are, in the most literal sense, made of stardust. Over 13.8 billion years, the universe has taken the simplest elements and cooked them in stars to create the chemistry needed for life. That material was scattered, eventually forming our solar system, our planet, and finally, you. The matter that makes up your brain has been on a cosmic journey, and now, it has become conscious. It has organized itself into a system complex enough to wonder about its own origins. This brings us back to the most grounded connection of all, the synchronization of your internal clock with the Earth's rotation. Your circadian rhythm is a direct biological reflection of your existence on a planet orbiting a star. Your brain does not just contain echoes of the cosmos, it is fundamentally tuned to it. So, your brain is a time-bending, self-cleaning, storytelling machine, synchronized to the rhythms of the planet and built from the dust of stars. This is not just a collection of interesting facts. It can be seen as a user manual for your own mind. Understanding the why behind sleep gives us clues about how to do it better. First, and most importantly, is to respect your sightgabers, those time givers. Your master clock, the SCN, depends on clear signals from the outside world. The most powerful of these is light. Exposing yourself to bright, natural sunlight early in the day helps to set your circadian rhythm, telling every cell in your body that the day has begun. Conversely, as evening approaches, it is helpful to send the opposite signal by dimming the lights and avoiding the intense, blue spectrum light from screens in the hours before bed. This blue light can suppress the release of melatonin and delay the onset of sleep. Second, is to create a routine for that brainwash. The process of clearing metabolic waste works best when sleep is deep and consolidated. A consistent sleep schedule, going to bed and waking up at roughly the same time, helps to stabilize your sleep and ensure you get enough of the deep, slow-wave sleep when this cleaning process is most active. Finally, you can use sleep to help your memory. Now that you know your brain is actively reorganizing and strengthening connections, you can use that to your advantage. Reviewing material you want to remember shortly before going to sleep can be effective. You are essentially leaving the information you want organized on top of the desk for your brain's nighttime work. This primes the relevant neural pathways, making it more likely that your sleeping brain will prioritize them for consolidation. We began this journey with a common experience: the mystery of time during sleep. We have traveled from that simple question deep into the brain's architecture and out to the scale of the cosmos. We have discovered that the time that can feel lost is, in fact, some of the most productive time in our entire day. During these hours, your brain is not at rest. Guided by a master clock, it keeps your body in rhythm with the earth. It undergoes a physical renovation, strengthening memories while washing itself clean of debris. And it sets consciousness free in the time-bending world of dreams, a place where it can construct entire lifetimes in minutes. Sleep, then, is not an absence. It is a different kind of presence. It is the time when the brain rebuilds the past, prepares for the future, and reconnects with the deep rhythms of its own heritage. The next time you close your eyes, do not think of it as shutting down. Think of it as initiating a process of quiet complexity and power. You are closing your eyes to the world so that the universe inside your head can get to work. Let me know about your own experiences with time and dreams in the comments below. What strange adventures has your brain taken you on? And if you want to continue exploring the quiet, incredible world inside your own head, and the science that helps us understand it, make sure to subscribe. Your brain's ancient shield and the origin of sleep. Every night, you perform a quiet and essential ritual. You lie down, your breathing slows, your muscles relax, and consciousness surrenders to something else. You fall asleep. In those hours, your brain is not dormant. It is a place of immense activity, sorting memories, clearing pathways, and preparing for the day to come. We think of sleep as a personal, biological need, a simple matter of being tired. But the story of your sleep is not that simple. It is not just about you. It is a story billions of years old, written not in biology books, but in the molten heart of our planet. There is a connection that links the quiet architecture of your mind, your ability to dream, to learn, to form a single complex thought, to a planetary scale force field, an invisible shield generated thousands of kilometers beneath your feet. The very structure of your intelligence could only have been built because Earth itself rose to our defense against an unending storm of cosmic radiation. This is the story of that ancient shield, the planet's violent history of protecting itself, and how the chaotic dance of a molten iron core ultimately helped make your deep, restorative sleep, and your very consciousness, possible. The invisible storm. Look up at the night sky. Between the familiar constellations and the faint glow of the Milky Way, the void seems peaceful, silent, empty. But it is not. The space between stars is filled with an invisible, high-speed hailstorm. It's called the galactic cosmic ray background. These are not rays in the sense of light. They are the shattered remnants of stars, the shrapnel from ancient, cataclysmic supernova explosions. They are atomic nuclei, mostly protons, stripped of their electrons and accelerated by galactic magnetic fields to almost the speed of light. Think of them not as tiny particles, but as microscopic cannonballs. They travel with such energy that they can pass through solid matter as if it were smoke. At this very moment, billions of these particles are passing through your body. Through the walls of your home, through the chair you're sitting on, and through your own skull, right through the delicate tissues of your brain. On the surface of the Earth, most have been slowed and broken apart, becoming less harmful. But in deep space, they are a relentless force. For most of Earth's history, this cosmic bombardment was a fundamental pressure. Any life trying to emerge had to contend with this constant, high-energy rain. For simple, single-celled organisms, the threat was manageable. Their structures were robust, their lifespans short. A damaged cell could be replaced. But for the future of life, for the dream of a creature that could think and remember, this unending storm presented a profound obstacle. A complex nervous system, a brain, is the most intricate and fragile structure known in the universe. And it would be a prime target. Earth's double defenses. Our planet, however, is not defenseless. It is protected by two distinct layers of security. The first, and most famous, is the magnetosphere. Earth's magnetic shield. It is not a solid barrier, but an invisible bubble of magnetic force, generated deep within the planet. Thousands of kilometers beneath our feet, the Earth's solid iron inner core is surrounded by a sea of liquid iron alloy, the outer core. The immense heat from the inner core causes this liquid iron to churn in massive, swirling currents. This movement of a conductive fluid, combined with the planet's rotation, creates a self-sustaining electrical dynamo. The geodynamo. And this dynamo generates the vast magnetic field that envelops our world. This is the shield. When charged particles from the Sun or the deeper cosmos travel towards us, they encounter this magnetic field. As a rule of physics, magnetic fields steer the path of moving charged particles. The magnetosphere deflects the vast majority of this radiation, guiding it around our planet like water flowing around a boulder in a stream. We see the evidence of this defense system in the auroras. They are the beautiful aftermath of captured solar particles funneled down magnetic field lines toward the poles, where they collide with atoms in our upper atmosphere and release their energy as light. A spectacular, silent battle, fought every second. But the magnetic shield is not perfect. It is weakest at the poles, and some high-energy cosmic rays still have enough momentum to punch through. This is where our second line of defense comes into play, the atmosphere. Our thick blanket of air is a formidable shield in its own right. When a cosmic ray that has breached the magnetosphere smashes into the upper atmosphere, it collides with a nitrogen or oxygen atom. The impact is so violent that it creates a cascade of secondary, lower energy particles. By the time this shower reaches you, its energy has been significantly diluted. Together, the magnetosphere and the atmosphere form a two-stage defense that makes the surface of Earth one of the most radiation-sheltered places in the inner solar system. But this defense was not always so secure. Its history is far more violent than we once imagined. A history of violence, the fluctuating shield. The story we often tell ourselves about Earth's magnetic field is a simple one. That it switched on, grew strong, and protected life, allowing it to flourish. The geological record, however, tells a much more chaotic story. The geodynamo is not a steady, reliable engine. It is turbulent and unpredictable. Paleomagnetists, scientists who study the history of Earth's magnetic field, have discovered its secrets locked away in ancient rocks. When volcanic lava or sediment settles, tiny magnetic minerals within it align with the planet's field at that moment, like microscopic compass needles. When the rock solidifies, that alignment is frozen in time. And that behavior is shocking. The record shows that the magnetic field is ancient, present for at least 3.7 billion years. But it has not been a constant companion. For vast stretches of time, it has weakened dramatically. Even more dramatically, it has completely reversed its polarity hundreds of times. During these reversals, which can take thousands of years, the main field collapses, leaving the planet protected only by a much weaker, less effective field. Earth's shields would have been, for a time, down. One of the most profound periods of weakness occurred during the Ediacaran period, from about 591 to 565 million years ago. For millions of years, the Earth's magnetic field was at an all-time low, less than 10% of its strength today. This was a prolonged state of vulnerability. During this time, the surface of the planet would have been subjected to a much higher dose of cosmic radiation. This period is fascinating because it comes right before one of the most explosive evolutionary events in our planet's history. Life did not evolve under the protection of a steady, reliable shield. It evolved on a planet whose primary defense was prone to fluctuations, collapses, and long periods of near-total failure. The Cambrian conundrum. Immediately following that long period of magnetic weakness came the Cambrian explosion, around 541 million years ago. Over a geologically brief span of time, the diversity of animal life on Earth erupted. Seemingly out of nowhere, the fossil record is suddenly filled with a bizarre and wonderful array of complex animals. Creatures with legs, antennae, shells, and the first primitive eyes appeared. Almost every major animal body plan that exists today originated in this single, dramatic burst. For a long time, it was tempting to connect these two events. A weak magnetic field followed by an explosion of life. Perhaps the field recovered and provided a new, safer environment that triggered the explosion. It's a compelling narrative, but scientific consensus suggests this is likely not the case. The Cambrian explosion is now thought to be the result of a perfect storm of other factors. Rising oxygen levels that fueled larger bodies, the evolution of a new genetic toolkit for building complex shapes, and the appearance of the first predators, which kick-started a rapid evolutionary arms race. This presents us with a new, more profound mystery. If the explosion of complex animal life wasn't caused by the magnetic shield, we have to look at the problem from the other direction. This new life, with its emerging nervous systems, had to survive in an environment of fluctuating radiation. The real question isn't how the shield enabled life, but how life, and specifically the brain, coped with a planet whose defenses were unreliable. To understand that, we have to look at another, even more ancient biological process: the origin of sleep itself. The birth of the brain and the ancient roots of sleep. When you think of sleep, you probably think of a brain shutting down. But sleep is profoundly ancient, far older than the brain. Scientists have observed sleep-like states in creatures with no central nervous system at all. Take the jellyfish. These simple animals have been in our oceans for over 500 million years. They have no brain, only a diffuse net of nerve cells. And yet, they sleep. At night, their pulsing rate slows, and they become less responsive. If deprived of this rest, they are sluggish the following day, a phenomenon called sleep rebound. This tells us something fundamental. Sleep, in its most basic form, did not evolve for dreaming or for memory. It evolved at the cellular level. It is a fundamental maintenance cycle baked into animal life, a time for conserving energy and clearing out the waste that builds up during periods of activity. This ancient, brainless sleep was the foundation. But as life exploded in complexity, something new was emerging. The simple nerve net of the jellyfish was giving way to a centralized bundle of neurons. The first brains. This was a monumental leap. A brain allows an organism to do more than just react. It allows it to process information, to learn, and to predict. It allows for strategy. It is the ultimate survival tool. But it comes at a cost. A brain is incredibly expensive to run, and more importantly, it is exquisitely fragile. Its function depends on the precise connections between billions of neurons. And this is where the story of sleep and the story of Earth's radiation shield begin to converge. The cognitive revolution and the need for deep sleep. As the brain evolved, so did sleep. It had to. The simple rest of a jellyfish was no longer sufficient for the demands of a thinking, learning animal. A more powerful kind of sleep emerged: deep sleep. In mammals and birds, this is divided into two main stages that cycle throughout the night: slow-wave sleep and rapid eye movement, or REM, sleep. Slow-wave sleep is the deepest, most restorative phase. During this time, your brainwaves become slow and synchronized. This is when your brain performs its most critical physical maintenance. The flow of cerebrospinal fluid increases dramatically, washing out toxic byproducts, like the amyloid beta plaques associated with Alzheimer's disease. It is also a critical time for the body to repair its tissues. Then there is REM sleep, the phase where your brain becomes highly active, almost as when you are awake. This is the stage of vivid dreaming. But it is far more than a nightly movie. REM sleep appears to be essential for cognitive and emotional maintenance. It's when your brain processes the day's events, solidifying important memories and integrating them into your existing knowledge. It's a process where unimportant connections are weakened and important ones are strengthened. It's also crucial for emotional regulation, helping to strip the raw emotional charge from difficult memories. This complex, two-phase system is not just about resting. It is a sophisticated, offline processing mode. It is the brain's software update, its nightly therapy session, and its janitorial service, all rolled into one. Without this advanced form of sleep, higher intelligence as we know it would be impossible. But this delicate maintenance cycle itself presents a vulnerability. During these critical hours of reorganization, the brain's machinery is particularly susceptible to disruption. And that brings us back to the invisible storm, the radiation hurdle for intelligence. For a complex brain to evolve, its neural architecture must be stable. The connections between neurons, the synapses, are the physical basis of memory and thought. But these connections are incredibly delicate. Modern neuroscience is revealing just how vulnerable this architecture is to cosmic radiation. Studies preparing for long-duration space missions have exposed rodents to galactic cosmic rays comparable to what an astronaut would experience. The results are sobering. The radiation was found to significantly damage key areas of the brain, including the hippocampus, the memory formation center, and the prefrontal cortex, the seat of decision-making. The animals showed increased anxiety and profound memory deficits. For a long time, it was assumed this damage came from the cosmic rays smashing into DNA. But recent research has uncovered a more insidious mechanism. It turns out that the radiation doesn't need to kill the cell to cripple it. The primary target appears to be the cell's outer membrane. The high-energy particles punch through these membranes, disrupting the neuron's fundamental ability to fire and receive signals. They also cause widespread inflammation. In essence, cosmic radiation doesn't just break the hardware. It corrupts the software by introducing static and disruption into the communication channels of the brain. Now, imagine our distant ancestors evolving on the African savanna. They were living on a planet with a magnetic field that, while stronger than in the Ediacaran, was still prone to fluctuations. A stronger, more stable magnetic field would have provided a crucial advantage. It would have lowered the background level of this brain-disrupting radiation. It would have created a neurologically quieter environment. This safer harbor didn't create intelligence, but it dramatically lowered the barrier for its evolution. It allowed the delicate process of building a brain capable of language and abstract thought to proceed without being constantly sabotaged. The planetary shield provided the peace and quiet necessary for the cognitive revolution to take hold. The modern laboratory, astronauts and the Mars problem. This connection between a planetary shield, radiation, and brain function might sound like a story from our deep past. But we are about to run a real-world experiment that will test this hypothesis. For the entirety of human existence, every single person has lived within the protective cocoon of Earth's magnetosphere. We are about to leave it. When we send astronauts to Mars, they will spend months traveling through interplanetary space, fully exposed to solar flares and galactic cosmic rays. They will be outside the shield. Based on animal studies, the projections are deeply concerning. NASA-funded research predicts that on a 3-year mission to Mars, some astronauts could experience severe anxiety or significant memory problems. Their ability to make quick, critical decisions could be impaired. The very minds we are counting on will be under direct assault from the environment of deep space. This Mars problem has turned this field of research from a historical curiosity into an urgent challenge. Scientists are scrambling for solutions, like drugs that might protect the brain's immune cells from radiation damage. But the existence of this problem is a profound reminder of our terrestrial origins. It demonstrates that our complex brains are not designed for the wider cosmos. They are exquisitely adapted to a planet that possesses a strong magnetic shield. We are creatures of the magnetosphere. And every night, when you go to sleep, you are reaping the benefits of that inheritance. The grand synthesis. Your brain's nightly inheritance. The story of your brain and your sleep began billions of years ago, not in a cell, but in the churning, molten heart of a young planet. The chaotic dance of liquid iron generated a shield. That shield was never perfect. It has flickered and failed for eons, a turbulent guardian. Yet, in its moments of strength, it provided a haven. It tamed the invisible storm of cosmic radiation just enough to allow the most complex structure in the known universe to emerge: the thinking brain. This brain demanded a new kind of sleep. Not the simple rest of a jellyfish, but a sophisticated maintenance cycle. A deep sleep capable of consolidating memory, processing emotion, and cleaning the very pathways of thought. This is the sleep you experience every night. So when you close your eyes tonight, you might remember this connection. Your personal world of thought, memory, and dreams is profoundly linked to the geologic soul of our planet. The ability to let your mind rebuild itself is a luxury afforded to you by a planetary defense system. The deep peace you find in sleep is a direct inheritance of Earth's ancient, chaotic, and ultimately successful battle against the cosmos. The iron in our planet's core and the iron in your blood are part of the same grand story. A story of how a planet built a shield, and that shield allowed a mind to emerge. A mind that could one day look back at the stars and wonder how it all came to be. If this journey through our planet's deep past gave you a new perspective on your own mind, please consider giving this video a like. It helps us understand what kind of stories you want to see more of. And if you'd like to join us for more explorations into the science that connects us all, make sure to subscribe. We'd love to hear your thoughts in the comments below. What was the most surprising connection for you? The universe is not a gentle place. It is filled with immense energy hostile to the delicate structures of life. And yet, on this one small, rocky world, something incredible happened. The planet itself, through the brute force of its own geology, created a sanctuary. It's a powerful reminder that we are not just living on the Earth, we are a part of it. Our biology is inseparable from its geology. Our consciousness is tied to its core. And the simple, nightly act of falling asleep is a testament to that deep, ancient, and powerful connection. How Earth's tilt hijacks your sleep hormones. There is a quiet tiredness that can settle in during the winter. A feeling that no matter how long you sleep, you wake up moving through water. An energy that feels borrowed and never quite your own. We often blame the cold, the general gloom of the season, or the stress of the holidays. But the reason for this shift is written on a much larger scale. It is a story not of weather, but of the tilt of our entire planet. It is a slight, 23.5-degree lean, an astronomical imperfection that has shaped the rhythm of life for billions of years. This tilt is powerful enough to reach into the chemistry of your brain and disrupt the very hormones that tell your body when to be awake and when to be at rest. This is a journey from the clockwork of our solar system down to the microscopic biology that governs your energy. Welcome to the Sleepy Scientist. If this kind of calm exploration into your own biology helps you feel more connected to the world, consider liking the video and subscribing to the channel. And wherever you are right now, whether it's a bright morning or a dark winter evening, feel free to share where you're watching or listening from. The grand story: a planet's peculiar tilt. To understand the fatigue you might feel in January, we have to zoom out. Past the roof, past the clouds, into the silent dance of the solar system. Our planet is doing two things at once: spinning on its axis, which gives us day and night, and making a 365-day journey around the Sun. If Earth's axis were perfectly upright relative to its orbit, the story of our lives would be very different. Every day would have 12 hours of light and 12 of dark, all year, everywhere. There would be no seasons. The climate in any one place would be permanent. But our planet is not perfect. It has a tilt. Imagine a line running through the Earth from the North Pole to the South Pole. This is its axis. Instead of pointing straight up, it is angled by about 23.5 degrees. This might not seem like much, but it changes everything. As Earth travels around the Sun, this axial tilt means that different parts of the planet receive more direct or less direct sunlight. Around June, the northern hemisphere is tilted toward the Sun. The Sun's rays arrive at a steep angle, like a flashlight shining directly on a surface. The light is concentrated and intense. This marks the summer solstice, bringing our longest days. 6 months later, in December, the Earth is on the opposite side of its orbit. Because the tilt remains pointed in the same direction in space, the northern hemisphere is now leaning away from the Sun. The same rays of light now arrive at a low, shallow angle. The light is spread out, weaker, and delivers less energy. This is the winter solstice, the moment of our shortest day and longest night. This is the engine of the seasons. It has nothing to do with our distance from the Sun. In fact, Earth is slightly closer to the Sun during the northern hemisphere's winter. It is entirely about the angle of sunlight, which determines the duration of daylight. In winter, your half of the world is leaning away from its energy source, plunging you into longer periods of darkness. In northern cities, the window of daylight can shrink to just a few hours. In the Arctic, the sun may not rise at all for weeks. This cosmic tilt has shaped all life. Animals migrate, hibernate, or change their codes. Plants know when to sprout and when to go dormant. And humans, despite our electric lights and heated homes, are still tied to this ancient planetary rhythm. We have largely insulated ourselves from it, but our bodies have not forgotten. They remember. And every winter, as the tilt of our world reduces the light, our internal machinery responds. A planetary wobble has shortened the days. Now, let's follow that signal as it travels from the sky and into your brain. The bridge, from planet to person. So, our planet is tilted. The days grow short. This feels like a distant fact, happening on a scale of millions of miles. How does an astronomical event translate into the biological feeling of being tired on a dark Tuesday morning? The bridge between the planet and the person is a single, powerful force: light. For almost all of history, the rising and setting of the sun was the only reliable clock. It told us when to be active and when to seek rest. In response, life evolved an internal timekeeping mechanism to synchronize biology with this daily cycle of light and darkness. This internal master clock is known as the circadian rhythm. Think of it as an operating system for the body, a 24-hour program that coordinates thousands of processes. This rhythm doesn't just manage sleep. It directs hormone release, body temperature, metabolism, and even mood. It is the quiet conductor of your biological orchestra. This master clock sets itself every day using one primary cue: light. The process begins in the eyes, but it isn't about vision. Within the retina, alongside the cells that form images, is a special class of photoreceptors. Their only job is to detect the ambient brightness of the environment. When light, especially the blue spectrum light of daytime, hits these cells, they send a direct signal to a tiny region in the center of your brain. This region is the suprachiasmatic nucleus, or SCN. It is no bigger than a grain of rice, but it is the physical location of your master clock. The signal from your eyes acts as a daily reset button. Morning light, in particular, is the critical message that says, the day has begun. Synchronize all systems for wakefulness. The SCN then broadcasts this information to local clocks throughout your body, in your liver, your muscles, your digestive system, ensuring they all run in sync. When the SCN receives that morning light signal, it tells your body to prepare for the day. And, importantly, it tells your pineal gland to stop producing the hormone that encourages sleep. This is where Earth's tilt begins its biological mischief. In summer, the system works perfectly. The sun rises early, giving your SCN a clear, powerful signal to start the day program. But in winter, the script is flipped. The sun rises later, often after an alarm clock has already forced you from bed. You wake up in darkness. Your SCN does not receive its crucial, good morning, signal. From its perspective, it's still night. The light you do get during the day is weaker, and for a shorter period. This creates a state of confusion for your master clock. The signal that should be a sharp, definitive start to the day becomes a weak and delayed whisper. This is called circadian misalignment. It's like living with a perpetual, low-grade jet lag. Your brain believes it's in a different time zone than your schedule demands. Your body is running a night program when you need to be alert. The conductor is confused, and the most immediate result is the disruption of two key hormones that govern your sleep-wake cycle. The astronomical event has officially crossed the bridge into your biology. The microscience, the hormonal disruption. Now we zoom in, deep into the biochemical machinery of the brain. The slow dance of Earth's orbit has delivered a weak light signal to your master clock. This discrepancy now triggers a cascade of hormonal confusion, leaving you feeling groggy and unmotivated. To understand this, we need to meet the two main players: the hormone of darkness and the hormone of wakefulness. First, melatonin. Often called the hormone of darkness, melatonin is the chemical messenger that signals to the body that it's time for sleep. Its production is elegantly simple. It's regulated by the absence of light. When your SCN detects darkness, it signals the pineal gland to begin converting serotonin into melatonin. As darkness falls, melatonin levels in your blood begin to rise. This doesn't knock you out like a drug. Instead, it gently opens the gate to sleep, lowering your body temperature and reducing alertness. Melatonin levels peak in the middle of the night, and then, as dawn approaches, the first signal of light tells the SCN to abruptly stop its production. This sharp drop is a critical part of the wake-up process. Second, cortisol. While famously known as the stress hormone, cortisol plays a vital role in our daily rhythm. Its release follows a distinct pattern, opposite to melatonin. In the hours before dawn, its levels begin a slow, steady rise, peaking shortly after you normally wake up. This pre-waking rise of cortisol is the body's quiet way of preparing for the day. It is not a sudden jolt, but a gradual turning up of the lights, boosting energy, sharpening focus, and preparing your systems for the day ahead. After this morning peak, its levels gradually decline, reaching a low point in the evening to allow melatonin to take over. Under normal, sunny conditions, these two hormones exist in a balanced, inverse relationship. As one rises, the other falls. This delicate dance is the essence of a healthy sleep-wake cycle. Now, let's reintroduce winter. The later sunrise and dimmer days disrupt this elegant relationship. First, the darkness of a winter morning means the stop signal for melatonin is delayed. When your alarm goes off at 7 a.m., it is still dark outside. Your SCN does not receive the powerful light cue it needs to halt melatonin production. The result is that a hormone that encourages sleep is allowed to linger in your system for hours after you've woken up. This is a primary reason for that profound grogginess, that sleep inertia that feels so difficult to shake on winter mornings. Your body is still in a physiological nighttime state. At the same time, the start signal for cortisol becomes less clear. The gentle, preparatory rise of cortisol is powerfully tied to the light-dark cycle. Without a strong cue of approaching day, that rise can become blunted or its timing can shift. Instead of a robust, energizing peak to start the day, you get a slower, weaker rise. It's like an engine that sputters and struggles to turn over. You are left with a perfect storm for seasonal fatigue. Too much of the sleepy hormone, melatonin, and not enough of the wake up hormone, cortisol. The story deepens with a third player, serotonin. This neurotransmitter, often associated with mood and well-being, has its production directly influenced by bright sunlight. This creates two parallel challenges in winter. First, reduced sunlight is linked to lower overall serotonin levels, which can contribute to low mood and irritability. Second, remember that melatonin is synthesized from serotonin. The extended hours of darkness send a prolonged signal for more melatonin production. The brain is left in a difficult state, low on a chemical associated with well-being, while simultaneously being supplied with a chemical that encourages rest. The intricate dance has turned into a clumsy stumble. The planet's tilt has orchestrated a full-blown hormonal disruption, leaving you sleepy, sluggish, and sad. So what? Recognizing the impact, we have journeyed from the cosmos to the chemistry of the brain. But what does this mean for daily life? This isn't just an abstract process. It's the reason life can feel heavier between November and March. For many, this manifests as the winter blues, a subclinical state that a large portion of the population experiences. It's not a formal diagnosis, but a collection of real symptoms. A general feeling of being sluggish, lower motivation, and a noticeable dip in mood on gray days. One survey by the American Psychiatric Association noted that for a significant number of people, mood worsens in the winter months. On the more severe end of the spectrum is seasonal affective disorder or SAD, a recognized clinical form of depression with a seasonal pattern. Estimates on prevalence vary, but it affects a meaningful portion of the population, especially in northern climates. Whether you have the full disorder or a milder case of the winter blues, the underlying hormonal disruption leads to a consistent set of experiences. 1. Oversleeping and daytime fatigue. This is the most direct consequence. People often report sleeping more but never feeling rested. You may find yourself hitting the snooze button repeatedly, feeling like you are moving through mud all morning. This is the lingering presence of melatonin, combined with the absence of a strong cortisol signal. The feeling of wanting to hibernate is a real biological urge. 2. Low mood and irritability. This is the signature of the serotonin deficit. The world can literally seem grayer. You might feel more pessimistic or have trouble finding pleasure in activities you usually enjoy. This isn't a failure of character, it's a predictable neurochemical shift. 3. Carbohydrate cravings. The intense craving for pasta, bread, and sweets in winter is also linked to serotonin. Eating carbohydrates can provide a temporary boost in brain serotonin, making you feel briefly better. Your brain, in a way, is pushing you to get its fix from food. 4. Difficulty concentrating. The combination of circadian misalignment and hormonal imbalance can affect cognitive function. Simple tasks can feel monumental. This brain fog is a common and frustrating symptom. 5. Social withdrawal. When you feel tired and low, the effort of socializing can seem overwhelming. This can create a difficult cycle, as social connection is a powerful mood booster. The most important part of this section is this: Understanding the biological mechanism behind these feelings is the first step toward reclaiming your energy. Knowing that your fatigue isn't a sign of laziness, but a predictable response to a hormonal imbalance, gives you power. Realizing your low mood isn't a personal failing, but a consequence of a serotonin deficit, allows you to stop blaming yourself and start looking for solutions. This is not something to just be toughed out until spring. The same science that explains the problem also points toward the solution. The solution: realigning your hormones. We cannot change the planet's tilt, but we can change the light signals our brain receives. We can use the same mechanism that causes the problem to stage a counter-offensive. Here are the most powerful, science-backed strategies to reset your internal clock. **1. Re-establishing the morning signal. This is the single most important intervention. The hormonal confusion begins with a weak morning light signal, so the most effective solution is to provide the brain with a clear and unambiguous one. Get outside. The best way is to get at least 10 to 30 minutes of natural sunlight within the first hour of waking. Even on a cloudy day, the light outdoors is exponentially more powerful than indoor lighting. Don't wear sunglasses. Allow the light to enter your eyes and signal your master clock. This powerful dose of morning light will abruptly stop melatonin production and help trigger a healthy cortisol rise, setting your clock for the day. Light therapy boxes. For many, especially in northern latitudes, getting natural morning sunlight is not practical. This is where light therapy, a clinically proven treatment for SAD, can help. A light therapy box mimics the intensity of sunlight. The standard recommendation is a box that provides **10,000 lux** of intensity. For comparison, a well-lit office is often only 300 to 500 lux. Position the box off to the side for about 20 to 30 minutes each morning while you eat breakfast or read. This provides the powerful "day has begun" signal your brain is missing. **2. Managing your light diet. Think of your light exposure throughout the day as a light diet. Daytime brightness. Work near a window if possible. Take short breaks to go outside. The more bright light you get during the day, the stronger the signal to your brain to be awake and alert. Evening darkness. In the evening, you want to do the opposite. Avoid bright light, especially from overhead sources and screens. Blue light from phones and computers tricks your SCN into thinking it's still daytime, which can suppress the natural rise of melatonin. Use dim, warm-toned lamps. Create a digital sunset by putting screens away an hour or two before bed. *3. Keep a consistent sleep schedule. Your circadian rhythm thrives on consistency. Going to bed and waking up at the same time every day, even on weekends, anchors your internal clock. When the natural light cues are weak, a consistent schedule provides a powerful behavioral cue that helps stabilize your rhythm. Sleeping in feels good, but it gives your body a form of jet lag, making Monday morning that much harder. *4. Strategic movement and exercise. Physical activity is a powerful tool. Exercise can boost mood and also acts as another synchronizing cue for your circadian rhythm. A workout in the morning or early afternoon can enhance alertness and reinforce the day signal. Intense exercise too close to bedtime, however, can raise body temperature and make it harder to fall asleep. *5. Consider your nutrition and supplements. Vitamin D. Our skin produces vitamin D from sunlight, and levels often drop in winter. Low vitamin D is linked to symptoms of depression. Many people in northern climates may benefit from supplementing with vitamin D3, but it's always best to consult with a doctor. Avoid simple carbs. While the craving is real, The temporary serotonin boost from sugary foods is often followed by a crash that leaves you feeling more tired. Focus on a balanced diet to maintain stable energy. By consciously implementing these strategies, you are no longer a passive victim of the seasons. You are actively managing your biology, providing the signals your brain needs to override the confusing messages sent by the tilted Earth. We began with a simple, relatable feeling: the profound fatigue of winter. We've traveled from the vast mechanics of our solar system, the 23.5-degree tilt that gives us seasons, down to the intricate world of neurotransmitters firing within the brain. We've discovered that this seasonal tiredness is a deep, biological echo of our planet's celestial dance. The shorter days of winter are not just a feature of the calendar. They are a powerful signal that penetrates our most ancient biological systems. This weakened light signal creates a state of circadian confusion. It allows the hormone of darkness, melatonin, to linger into our mornings. It blunts the energizing rise of cortisol. And it can starve our brains of serotonin, a chemical linked to well-being. Our bodies are, in effect, hijacked by the seasons. But the most empowering part of this story is that we are not helpless. Understanding this mechanism is the key to the solution. The very same force that causes the problem, light, is also our most powerful tool to fix it. By deliberately seeking bright light in the morning and embracing darkness in the evening, we can re-establish the clear, rhythmic signals our bodies need to thrive. The link between a planet's tilt and your personal biology is a profound reminder of how deeply we are connected to the natural world. Our modern lives may have insulated us, but they have not severed this fundamental bond. By recognizing this connection, by understanding the science that governs our internal seasons, we gain a new level of control over our own well-being. You have the power to sync your body, take back control of your hormones, and make winter a season not just of endurance but of energy. If you found this exploration into your own biology fascinating, consider subscribing and turning on notifications for more deep dives into the science of you. And we'd love to hear from your experience. Do you feel the effects of the seasons? Share your story in the comments below. Your brain's nightly trip to the edge of the universe. There is a quiet, internal world that each of us travels to every night. It is a space as vast and as silent as the void between stars, yet it exists entirely within our own minds. This is not science fiction. It is the story of your deepest sleep, a journey happening inside your head that is both profoundly personal and strangely universal. It is a time when the mind is not simply resting, but quietly reorganizing its own internal landscape in ways that echo the grand, slow rhythms of the cosmos itself. Welcome to the Sleepy Scientist. If this kind of calm exploration into the world inside our own minds helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether in a quiet room at the end of the day, or listening somewhere in between, feel free to share where you're watching or listening from. The cosmic quiet of deep sleep. During the day, the brain is a landscape of activity. Thoughts and experiences accumulate, much like cosmic dust settling in the wake of distant events. But as we fall into the deepest stage of sleep, a phase known as N3, or slow wave sleep, this landscape transforms. The frantic electrical chatter of wakefulness gives way to something else entirely. Brainwaves slow into deep, rhythmic undulations called delta waves, some of the slowest and largest produced by the human brain. Billions of neurons begin to fire in synchrony, a slow, hypnotic pulse that spreads across the cortex. In this state, neurons alternate between brief moments of firing, known as up states, and periods of near-complete silence called down states. This is not chaos, it is an orchestrated quiet. Your heart rate slows, your breathing becomes steady, and your muscles relax. You are difficult to wake now because the frontal areas of the brain, which manage so much of our waking life, have finally withdrawn to recharge. But this quiet is not empty. It is a carefully managed state, creating the perfect conditions for the brain's most essential work. Memory consolidation, the brain's filing system. Within this silence, the brain begins the delicate process of memory consolidation. When we are awake, new information and experiences are temporarily held in a part of the brain called the hippocampus. It is an efficient, but not a permanent, storage solution. Deep sleep changes this. The slow waves of N3 sleep appear to trigger a kind of dialogue between the hippocampus and the neocortex, the vast outer layer of the brain responsible for long-term storage. During this dialogue, recent memories are replayed, reactivated, and carefully shuttled to the neocortex to be woven into the fabric of what we already know. This process is especially important for declarative memories, the facts, events, and knowledge we gather throughout the day. Studies suggest that this nightly transfer significantly enhances our ability to recall information later. Without sufficient deep sleep, this process falters, and memories can remain fragmented and unclear. It is as if our experiences are stars, and during deep sleep, the brain is the patient architect, arranging them into lasting constellations of understanding. The glymphatic system, your brain's cleanup crew. While memories are being filed, another, equally important process unfolds. This is the work of the glymphatic system, the brain's own dedicated cleaning service. Though less discussed than memory, its function is fundamental. Active primarily during deep sleep, this system uses cerebrospinal fluid to flush through brain tissue, clearing away metabolic waste that accumulates during our waking hours. Among these waste products is beta amyloid, a protein that, when it builds up, is associated with neurodegenerative diseases. The slow waves of deep sleep seem to amplify this process. Glial cells appear to shrink, widening the channels between them and allowing the fluid to flow more freely, washing away toxins. At the same time, the brain is pruning itself, weakening unimportant neural connections to make room for stronger, more efficient pathways. It is like a quiet universal expansion, clearing away debris to make space for new structures to form. This nightly cleaning is not just housekeeping, it is essential for maintaining a healthy, functional mind. The cosmic silence of sleep. What makes this state feel so much like a silent void is the nature of the neuronal, down states. During these fractions of a second, large populations of neurons go completely quiet. External sensory input is largely blocked. The brain's energy consumption drops significantly. There are no complex narratives or vivid dreams that define other stages of sleep. It is a time for internal reorganization, a conversation between different parts of the brain without outside interruption. If you are woken from this stage, you often feel groggy and disoriented, as if pulled back from a great distance. The cortex needs time to return to full awareness. And yet, this silence is not absolute. It is a state pregnant with potential. Subtle sounds or smells introduced during deep sleep can still be processed, sometimes strengthening memories or even forming new, weak associations. The quiet is not emptiness, but a state of profound readiness, recalibrating the brain for the explosions of learning and experience that the next day will bring. The connection to the universe. Prioritizing this nightly journey is not merely about avoiding tiredness. It is about allowing the brain the time it needs to perform this intricate and essential maintenance. A consistent sleep schedule, a calm transition into the night, and a dark, quiet environment are all invitations for the brain to enter this restorative state. As we learn more about these processes, it is difficult not to see the parallels between our own internal worlds and the universe at large. Just as the cosmos is governed by rhythms of expansion and contraction, of activity and silence, so too is our brain. Our memories form like stars, are organized into galaxies of knowledge, and are sometimes allowed to fade. The quiet hum of our sleeping brain echoes the silent, steady mechanics of the cosmos. There is something humbling in this connection. It suggests that our own minds, in their own small way, participate in the same fundamental patterns that shape everything. So, the next time you lay your head down to sleep, remember that you are not just turning off for the night. You are embarking on a quiet, essential journey. Your brain is becoming a cosmos unto itself, cleaning, organizing, and preparing for the day ahead. In that silence, you are not just resting, you are renewing. Until next time, sleep well. Your brain reverses chaos every single night. Have you ever felt your brain grow full as the day ends? A kind of mental clutter where thoughts feel scattered, focus is distant, and you feel as though you're running on empty. This is more than a feeling. It's a reflection of a quiet, fundamental process. A kind of biological disorder that scientists sometimes refer to with a term from physics: entropy. It is a measure of chaos, and through our waking hours, the disorder inside our own minds steadily grows. But what if every night, your brain performed a quiet, system-wide reset? What if sleep was not just rest, but an active, powerful process of rewinding that chaos, of restoring order from a state of growing disarray? And what if that nightly process mirrored, in some strange way, the same principles that keep the universe itself in balance? This is a journey into that process. A calm exploration deep into the architecture of the mind, and out to the patterns of the cosmos. We will uncover how the simple act of closing your eyes begins a sequence of events that cleanses, repairs, and restores the brain, pushing back against the slow march of disorder. This is the story of how your brain, every single night, reverses chaos. The daily descent into chaos. To appreciate the quiet work of the nightly reset, we first have to understand the state it is responding to. Every moment you are awake is a moment of almost impossible complexity. Your brain, an organ of just 3 pounds, coordinates everything you think, feel, and do. It's a biological computer running countless simultaneous processes. But this performance has a cost. It generates waste. It creates disorder. It increases a state we can describe as biological entropy. Think of it like a forest ecosystem. When the forest is awake with light, it is alive with activity. Energy is consumed everywhere, but all this activity produces byproducts. Nutrients are depleted from the soil. Fallen leaves and branches accumulate. The pathways that animals use become worn. By the end of the day, the system is cluttered and tired. It needs the quiet of the night to decompose waste, to regenerate nutrients, to let the pathways rest. Your brain is that ecosystem. From the moment you wake, your roughly 86 billion neurons begin to fire, forming the complex electrical patterns of your thoughts and perceptions. Each of these signals is a chemical event that consumes energy. The main fuel for this is glucose, which the brain uses at a remarkable rate. While making up only about 2% of your body weight, the brain consumes around 20% of your body's total energy. This constant, high-energy activity generates byproducts, a kind of neuronal exhaust. One of the most important of these is a molecule called adenosine. Adenosine serves as a direct link between the brain's activity and the feeling of sleepiness. As your neurons fire, they break down a molecule called adenosine triphosphate, or ATP, the energy currency of all life. As ATP is used, adenosine is released as a byproduct, and it begins to collect in the spaces around your neurons. Throughout the day, the longer you are awake and the more mentally active you are, the more adenosine builds up. This buildup is not silent. Adenosine influences the activity of your neurons, making them less likely to fire. It quietly signals to your arousal systems that it's time to slow down. This is the biological basis for what we call sleep pressure. That growing feeling of drowsiness, the sense that your mind is becoming foggy, that is the direct result of adenosine accumulation. It is the brain's internal measure, telling you that energy is running low and the system is becoming cluttered. Caffeine works by fitting into this system. Its molecular shape is very similar to adenosine's, allowing it to block the adenosine receptors without activating them. It's like placing a key in a lock that fits but doesn't turn. The adenosine that has built up can no longer deliver its slow down message. You feel alert not because you have more energy, but because you have temporarily muted the signal telling you that you're tired. The adenosine is still there, waiting. When the caffeine wears off, the accumulated sleep pressure can return all at once. But adenosine is just one part of the story. Waking life also creates what scientists call oxidative stress. Just as burning fuel creates exhaust, cellular energy production creates unstable molecules called free radicals. These molecules can damage proteins, lipids, and even DNA. While the brain has defenses, the intensity of waking activity means this damage slowly accumulates over the course of the day. Studies on sleep deprivation have shown that a lack of sleep is associated with increased signs of oxidative damage to cells. This suggests that not only does wakefulness cause wear, but it also hampers the very systems meant to repair it. So, as your day concludes, your brain is in a state of high biological entropy. It's cluttered with metabolic byproducts like adenosine. Its immediate energy reserves are low. Its cells are dealing with oxidative damage. Its neural networks are in a state of flux, holding onto many new, temporary, and perhaps inefficient connections from the day's learning. The system is in a state of growing disorder. This is the chaos that sleep must reverse. If it doesn't, the clutter builds, leading to problems with thinking, mood, and over the long term, an increased risk for disease. The ecosystem is on the verge of exhaustion, and it is waiting for the deep, restorative quiet of the night. A universal echo. Before we look at the precise ways sleep cleanses the brain, there is something quietly humbling to consider. The struggle your brain undertakes every night against chaos is not unique. It is, in a profound way, a small echo of a fundamental principle that seems to govern the entire universe. This principle is the second law of thermodynamics. In its simplest form, it states that the total entropy, or disorder, of an isolated system tends to increase over time. Things fall apart. A structure of sand will inevitably crumble back into a shapeless pile. A star will burn through its fuel and scatter its matter across space. This appears to be the universe's default direction, a slow march toward chaos. And yet, when we look around, we do not see a universe of uniform, featureless disorder. We see pockets of incredible order. We see galaxies, stars, planets, and life. This is possible because the universe is not one simple, isolated system. Within the larger trend of increasing entropy, local pockets of order can form, but they always do so at the cost of increasing disorder somewhere else. Gravity is a perfect example. In the early universe, matter was a nearly uniform, chaotic cloud. But gravity, an organizing force, began to pull this matter together. It created dense clumps that would eventually become stars and galaxies. In these pockets, entropy decreased as order emerged from chaos. But this came at a cost. The process of star formation radiated enormous amounts of energy out into space, increasing the overall entropy of the universe. The universe creates order in one place by exporting disorder to another. It maintains a kind of balance. Now, let's bring this large, cosmic idea back down to the 3-pound universe inside your skull. Your waking brain is a system that is constantly increasing its own internal, biological entropy. It consumes energy, produces waste, and creates cognitive clutter. If this continued without check, the brain would eventually be overcome by this disorder. But it is not, because sleep is the brain's way of exporting that chaos. It is the counterforce that pushes back against the tide of entropy, creating a local pocket of profound order. Much like gravity pulling cosmic dust into a star, sleep takes the disordered state of the waking brain and actively reorganizes it. It doesn't break the laws of physics, it works within them. It uses energy to perform the vital work of cleaning and repair, so that the system can function again the next day. What is truly remarkable is the similarity in the architecture of these vastly different systems. In a 2020 study, an astrophysicist and a neurosurgeon compared the network of neurons in the human brain to the cosmic web of galaxies. They found that despite the difference in scale, a staggering 27 orders of magnitude, the two networks showed surprising similarities in their structure. The distribution of matter in the cosmic web seems to follow a similar pattern to the arrangement of the brain's neuronal network. Both systems are made of a complex web of filaments and nodes, neurofilaments connecting neurons, and vast filaments of matter connecting galaxies. In both the brain and the universe, these active nodes make up only about 30% of the total mass and energy. The other 70% is made of apparently passive components, water in the brain, and dark energy in the universe. The researchers concluded that even though the forces at play are completely different, the evolution of these two networks likely follows similar physical principles of self-organization. This is not to say your brain is a miniature universe, but that the principles of how networks balance order and chaos are so fundamental they seem to emerge at every scale of existence. So when you lie down to sleep, you are not just performing a personal act of rest. You are taking part in a process that echoes the fundamental balancing act of the cosmos. Your brain is about to perform its own nightly version of housekeeping, pushing back the chaos to allow for another day of complex, ordered, conscious experience. The Great Unwinding, sleep's master plan. As you drift into the first stages of sleep, your brain does not simply shut down. It begins a highly active and carefully orchestrated program of restoration. This is not a passive process, it is an active reversal of the day's accumulated chaos. We can see this quiet work as three core missions: the cleanup, the refueling, and the repair. Part A. The cleanup and the glymphatic system. For a long time, scientists were puzzled by a simple question: how does the brain clean itself? The rest of the body uses the lymphatic system, a network of vessels that drains waste from tissues. But the brain, protected by the blood-brain barrier, seemed to be missing this system entirely. The discovery of the answer, just over a decade ago, changed our understanding of sleep. The brain has its own unique waste disposal system, now known as the glymphatic system. It is a quiet, ingenious system that uses the cerebrospinal fluid, CSF, the clear liquid that surrounds the brain, as a cleaning agent. Here is how it works. During the day, the glymphatic system is mostly inactive. The space between brain cells is relatively narrow. But as you enter deep, non-REM sleep, something remarkable happens. The brain's glial cells appear to shrink, causing the space between them to expand by as much as 60%. This opens the channels for cleaning. At the same time, the rhythm of your brain changes. The fast, complex brainwaves of wakefulness give way to the large, slow, synchronized waves of deep sleep. Research has revealed that these slow electrical waves are perfectly coupled with another, slower rhythm, a gentle pulsation of cerebrospinal fluid. Researchers observed a sequence. First, a slow wave of neural activity would pass through a brain region, causing the neurons to go quiet. A moment later, blood would flow out of that region, as the quiet neurons needed less oxygen. This created a drop in pressure, and into that space a wave of CSF would rush, washing through the newly expanded channels. This process is like a quiet, nightly rinse for the brain. The CSF flows through the tissue, collecting the metabolic waste that accumulated during the day. This includes the adenosine that causes sleep pressure, but also more toxic proteins like beta amyloid and tau. These are the same proteins that, when they build up into plaques and tangles, are associated with Alzheimer's disease. The waste-filled CSF is then flushed out of the brain, eventually entering the body's main circulation to be disposed of. The glymphatic system is overwhelmingly active during sleep, specifically during deep, slow-wave sleep. Its activity is suppressed by about 90% when we are awake. This makes sense. The brain cannot be in a state of high performance and deep cleaning at the same time. The brain waits until the traffic of waking consciousness has subsided to begin the cleanup. This discovery provides one of the most compelling reasons why we sleep. Sleep is not just for resting the mind, it is for cleaning it. A single night of poor sleep can impair this process. Chronic sleep deprivation may allow these toxic proteins to build up, which could help explain the strong link between poor sleep and the risk of neurodegenerative diseases. After a night of normal sleep, levels of amyloid and tau have been shown to be higher in the blood the next morning, consistent with them being cleared from the brain and moved into the bloodstream. The glymphatic system is the brain's quiet solution to its waste problem, a nightly rinse cycle that reverses the clutter of the day, all orchestrated by the deep, powerful rhythms of sleep. Part B. Refueling the engine. Cleaning the system is only the first step. The second critical mission of sleep is to refuel the brain's energy stores, preparing it for the demands of the next day. As we've discussed, the energy currency of the body is adenosine triphosphate, or ATP. Wakefulness is an ATP spending state. Every thought and sensation requires the breakdown of ATP. This process releases adenosine and drives sleep pressure. One might think that sleep simply slows down ATP use, allowing levels to gradually return to normal. But the reality appears to be more active. Research measuring brain energy levels found that as animals entered non-REM sleep, ATP levels in wake-active parts of the brain didn't just stabilize, they were significantly restored. This restoration was tightly dependent on sleep itself. When the animals were kept awake, it was prevented. The amount of energy restoration was also directly correlated with the intensity of delta wave activity, the signature of deep sleep. The deeper the sleep, the greater the energy rebound. The explanation for this lies in the balance between energy production and consumption. During the slow wave activity of deep sleep, overall neuronal firing is greatly reduced. This sharp drop in activity means the brain's energy consumption falls dramatically. The power plants of the cells, however, continue to produce energy. With demand so low, a significant surplus is created. This surplus is a critical part of the restorative process. Abundant energy signals to the cell that it is time for building and repair. With this surplus, the brain can create new proteins, repair damaged cell parts, and replenish its important glycogen stores. It is the biological equivalent of restocking the shelves and repairing the machinery overnight, all fueled by the energy surplus created by the quiet of deep sleep. This process essentially resets the brain's energy budget. It pays off the energy debt from the day and builds up a reserve for tomorrow. This is why you feel not just less tired, but mentally energized after a good night of sleep. Your brain's batteries haven't just been topped off, they've been deeply restored. Part C. The Nightly Gardeners. With the system clean and refueled, a final, more delicate mission can begin. This is the work of repair and reorganization, carried out by cells that act as the brain's nightly gardeners. At the center of this work are the microglia. These are the resident immune cells of the nervous system. For a long time, they were thought of as simple sentinels, only acting to fight infection or clear away dead neurons. But recent research has shown their role is far more subtle and vital, especially during sleep. Studies have shown that microglia are most active while we sleep. Their behavior appears to be controlled by the same chemical that helps wake us up, norepinephrine. During the day, norepinephrine levels are high, keeping us alert. But this same chemical also keeps the microglia in a less active, surveillance mode. As we fall asleep, norepinephrine levels fall. This drop acts like a switch, allowing the microglia to begin their important work. They become dynamic gardeners of the brain's network of connections, or synapses. Throughout the day, as you learn and experience new things, your brain forms countless new synaptic connections. Many of these are temporary or inefficient. The microglia move through these connections, pruning away the unnecessary ones and helping to strengthen the important ones. This process is essential for learning and memory. It's like a gardener trimming away weaker branches to allow stronger ones to grow. It reduces the noise in the system, making communication between neurons more efficient. Beyond pruning, microglia are also the brain's repair team. They move around, extending and retracting their fine branches, physically checking the health of neurons and synapses. They clear away small bits of cellular debris and help repair minor damage. This work is complemented by an even more fundamental repair process, DNA repair. The high metabolic rate of the waking brain can cause oxidative stress and lead to DNA damage. Sleep appears to be the primary time when the body increases the activity of molecules needed to fix this damage. While we are awake, the need to keep genes active for brain function might make it difficult to pause and repair the genetic code. Sleep provides the necessary downtime for enzymes that specialize in DNA repair to patch up the breaks and lesions that have accumulated. This helps maintain the integrity of our neurons, preventing mutations that could lead to dysfunction. Together, these processes represent the deepest level of the nightly reset. The glymphatic system washes the brain on a large scale. The energy surplus refuels it. But it is the quiet, diligent work of the microglia and DNA repair systems that restores order at the cellular and molecular level. They are the gardeners who tend to the very fabric of the mind, working in the dark, in the quietest hours of sleep, ensuring the garden of the brain is ready for a new day. The rhythms of renewal. The brain's nightly reset is not a random process. It's a symphony, conducted by a series of precise and powerful rhythms, brainwaves. These oscillating patterns of electrical activity are the language of the brain, and during sleep, they become the driving force behind restoration. They are the signature of the shift from chaos to order. When you are awake, your brain's electrical activity is characterized by high-frequency, low-amplitude waves. They are desynchronized and complex, reflecting the countless different conversations happening between neurons. It's the sound of a system alive with activity. But as you begin to fall asleep, the rhythm changes. You enter the stages of non-REM, NREM, sleep, and the waves become slower and more synchronized. In stage 2 sleep, which makes up about half the night, the brain shows characteristic bursts of activity called sleep spindles. These are thought to play a role in memory consolidation, the process of taking fragile, temporary memories and converting them into stable, long-term storage. This is a first step in filing away the day's experiences, reducing cognitive clutter. But the most profound shift happens when you enter stage 3 NREM sleep, also known as deep or slow-wave sleep. Here, the brain becomes dominated by huge, powerful, low-frequency delta waves. These are the most synchronized waves the brain produces. It is as if the entire population of neurons, which was chattering independently during the day, now begins to move to the same slow, powerful rhythm. This is the visual representation of order emerging from chaos. This synchronized quiet is what allows the glymphatic system to do its work and the brain's energy stores to be replenished. The brain cycles between this deep NREM state and a very different one, REM, or rapid eye movement sleep. During REM sleep, the brainwaves suddenly speed up again, looking remarkably similar to the patterns of an awake brain. Your breathing and heart rate become irregular, and your muscles are temporarily paralyzed. This is the stage where we experience our most vivid dreams. While deep NREM sleep seems to be primarily for physical and chemical restoration, REM sleep appears to be more for mental and emotional reorganization. It's during REM sleep that the brain sorts through the day's emotional experiences, helping to process them. It's also believed to be a time of creativity, where the brain makes new connections between different ideas, a process that might be reflected in the strange nature of our dreams. The cycle between NREM and REM repeats roughly every 90 minutes. In the early part of the night, you spend more time in restorative deep sleep. As the night goes on, the periods of REM sleep get longer. This architecture ensures the brain gets the right kind of restoration at the right time. First, the deep physical cleaning and refueling, then more time for mental and emotional processing. These brain waves are not just byproducts of sleep, they are the conductors of the process. The slow waves of deep sleep actively drive the flow of fluid that cleanses the brain. The spindles of stage 2 sleep help consolidate memories. And here we find one last, quiet echo of the cosmos. As we mentioned, analysis has revealed a structural similarity between the brain's neuronal network and the universe's cosmic web. The brain waves that pulse through our neural network, creating order from chaos, are in a way analogous to the gravitational fluctuations that shaped the early universe, pulling chaotic matter into the ordered structures of galaxies. Both are rhythms that create structure and complexity from a more disordered state. Every night, your brain cycles through these profound rhythms, a dance of electricity and chemistry that washes, refuels, repairs, and reorganizes. It is a journey from the complex activity of wakefulness to the ordered quiet of deep sleep, and then to the creative complexity of the dreaming mind. It is a process that is both deeply biological and quietly beautiful, a nightly symphony that ensures the chaos of yesterday does not consume the potential of tomorrow. The science of sleep is a field that keeps revealing just how critical this nightly process is for every part of our health. What we've discussed today is just a glimpse into this quiet, incredible world. If you have ever felt that clarity after a good night of sleep, that feeling of a mental slate wiped clean, you have experienced the end result of this amazing process of reversing chaos. I'm curious to hear from you. What is the most profound difference you notice in yourself after a truly good night of sleep versus a poor one? Feel free to share your experience in the comments below. Your story is a personal testament to the power of this nightly reset. And if this calm exploration into the brain and the cosmos is something you find interesting, consider subscribing for more journeys into the science of the human body and mind. There is a universe of knowledge to discover, both out there and within ourselves. So, we return to where we began. That feeling of a full brain at the end of a long day. We now know this is not just a feeling, it is the tangible result of biological entropy. It is the accumulation of metabolic waste, the depletion of energy, and the clutter of a day's worth of information. It is the natural, slow descent into disorder. But we are not left to this chaos. We are equipped with one of the most elegant and powerful systems in the known universe, the restorative power of sleep. Sleep is not an absence of activity. It is a different kind of activity. It is a deliberate program designed to systematically push back against entropy. It is the glymphatic system's rhythmic wash cycle, flushing away the proteins that threaten our future. It is the restoration of ATP, a powerful wave of energy that refuels the mind. It is the diligent work of the microglial gardeners, pruning and repairing the very connections that form our thoughts. And it is all conducted by the powerful, hypnotic rhythm of brainwaves, shifting from the frantic pace of day to the deep, restorative pulse of the night. In this nightly reset, we see a quiet parallel to the cosmos itself. Just as the universe builds pockets of order, stars, galaxies, life, out of a primordial chaos, your brain builds order out of the chaos of your waking life. It is a fundamental balancing act, played out every 24 hours inside your own head. So the next time you feel the gentle pull of sleepiness, the pressure of adenosine building, do not see it as an inconvenience. Recognize it for what it is, an invitation to engage in a profound act of self-preservation and renewal. An invitation to let your brain perform its nightly miracle, to reverse the chaos, and to align the cosmos within. Sleep is not lost time. It is the time when you are made whole again. You are a small part of a large cosmic pattern. Have you ever looked up at the night sky and felt a quiet sense of scale? A feeling of being a small part of something vast, ancient, and silent. This is a common human experience, a sense of perspective that can arrive in moments of stillness. We see the faint band of the Milky Way, knowing it contains hundreds of billions of stars, and we are on one small world, in one part of it all. That feeling is not just a philosophical thought. The sense of being a small, living part of a large, interconnected system is a deep biological reality. Your most routine daily act, the process of falling asleep, is a quiet, unconscious participation in a cosmic rhythm. A rhythm that connects the atoms in your body to the rotation of the Earth, the light of the sun, and the history of the stars. This is a journey from the quiet of a bedroom to the heart of a star, from the spark of a single neuron to the slow turning of galaxies. We will explore how you are not simply living in the universe. The universe is living through you. Welcome to the Sleepy Scientist. If this kind of calm exploration into your connection with the cosmos helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether in a city, a forest, or somewhere quiet in between, feel free to share where you're watching or listening from. The ache of insignificance. Let us stay with that feeling of scale for a moment. It is an idea amplified by modern science. Images from the Hubble and James Webb telescopes show us what appear to be empty patches of sky. But over long exposures, those patches are revealed to be filled with galaxies. Not stars, but entire galaxies, each a collection of billions of suns. Thousands of them in a section of the sky no larger than a grain of sand held at arm's length. The numbers are difficult to comprehend. Perhaps 2 trillion galaxies in the observable universe, each with its own population of stars. Our Sun is one of roughly 100 to 400 billion in the Milky Way, a fairly average star in a quiet spiral arm. And Earth is just one planet. In the face of this vastness, it is natural to feel small. Our lives, our concerns, our accomplishments, all seem to diminish against the background of cosmic time and distance. This feeling is also shaped by the silence. The universe does not appear to operate on principles of meaning or intention. It operates on gravity, thermodynamics, and quantum mechanics, impersonal forces that produce stars and black holes with the same dispassion. We, with our consciousness, our art, and our search for meaning, can feel like a brief anomaly in a cold, empty space. The question this raises has occupied thinkers for centuries. How do we find our place in a universe that was not, by all appearances, made for us? The answer, it seems, is not found in distant nebulae or swirling galaxies. The answer is within us. It is in our blood, our bones, and most profoundly, in the rhythm that guides us to sleep each night. The ancient pact, light and life. Our story begins not with humans, but with the first life on a young Earth, some 3.8 billion years ago. The planet was spinning, creating a predictable cycle of light and darkness. This was the most powerful and consistent environmental pressure on new life. It was a cosmic metronome ticking every 24 hours. Survival depended on adapting to its rhythm. Early organisms, like ancient cyanobacteria, developed a fundamental ability to anticipate. They evolved internal mechanisms to prepare for the daily arrival of solar radiation and to use its energy. They learned to photosynthesize during the day and to repair and conserve energy at night. This was not a choice, it was a result of natural selection. Organisms that could synchronize their internal functions with the external cycle of the sun were more likely to survive and reproduce. Those that could not, perished. This internal timekeeping mechanism is what we now call the circadian rhythm. Billions of years later, every complex animal on Earth carries a version of that mechanism in its genetic code. You are a descendant of those early organisms. The clock is no longer just for photosynthesis. It has become a master regulator of nearly all of biology. It influences when you feel awake and when you feel sleepy. It governs the release of hormones, the rise and fall of body temperature, the efficiency of metabolism, and the clarity of your mind. The primary gear in this ancient clock is light. When light enters the eye, it does more than create vision. A special set of cells in the retina, called intrinsically photosensitive retinal ganglion cells, act as messengers. Their main purpose is to detect the presence of ambient light and send a signal directly to the center of the brain. This signal travels to a small region in the hypothalamus called the suprachiasmatic nucleus, or SCN. The SCN is the body's master clock. It is a tiny cluster of just 20,000 neurons, smaller than a grain of rice. Yet it holds the responsibility of keeping the entire body synchronized with the rotation of the Earth. When daylight enters your eyes, the SCN receives the signal and initiates a "wake up" message to the rest of the brain and body. It suppresses the production of melatonin, sometimes called the hormone of darkness, and increases cortisol to promote alertness. As daylight fades, the light signal weakens. The SCN registers this change and reverses the process. It signals the pineal gland to begin its nightly release of melatonin, which causes drowsiness and prepares the body for sleep. If the SCN is damaged in laboratory animals, their rhythmic behaviors dissolve. They sleep and eat at random intervals. They become biologically disconnected from the 24-hour world. Inside these neurons, the clock functions through a precise molecular feedback loop. A set of clock genes, with names like clock, BMAL1, period, per, and cryptochrome, cry, work in concert. Proteins from the clock and BMAL1 genes turn on the per and cry genes. As per and cry proteins accumulate during the day, they eventually block the activity of the very genes that created them. Then, over the course of the night, these proteins degrade, the block is removed, and at dawn, the cycle starts again. This process takes, remarkably, approximately 24 hours. Nearly every cell in the body contains a version of this molecular clock, but it is the SCN that synchronizes them all, ensuring the entire biological system operates on a single, planetary timetable. The whispers of the cosmos. Light is the most powerful cue that anchors our biology to the planet. But it may not be the only Zeitgeber, a German word meaning time giver, that the universe provides. The body appears to be attuned to subtler signals as well, faint whispers that may also help keep our internal clocks adjusted. One of these is the Earth's own electromagnetic field. The space between the planet's surface and the ionosphere, about 60 miles up, acts as a giant resonant cavity. This cavity is constantly energized by thousands of lightning strikes occurring around the globe every second. This activity creates a planetary hum, a set of extremely low frequency waves known as the Schumann resonances. The fundamental frequency of this global electrical pulse is approximately 7.83 Hz. Here, we find a remarkable coincidence. The brain also operates on electrical frequencies. In a state of calm, relaxed alertness, the brain produces alpha waves, which fall between 8 and 13 Hz. In the early stages of sleep or deep meditation, it produces theta waves, from 4 to 8 Hz. The fundamental frequency of the Earth's electromagnetic field sits at the intersection of these two states. For a long time, this was considered a coincidence. Some research, however, now hypothesizes that the Schumann resonance may act as a subtle, stabilizing signal for our biology. This idea remains a topic of scientific investigation, but it points to a potentially deeper connection between planetary and biological rhythms. Another subtle signal may come from the Earth's geomagnetic field. Generated by the planet's molten iron core, this is the same field that directs a compass needle. As the Earth rotates, our bodies move through this field, which fluctuates in a predictable daily cycle. For decades, the idea that humans could detect this field was dismissed. Birds, turtles, and bees were known to use it for navigation, but humans were thought to be unaware of its influence. This view is now being reconsidered, and the key may again lie in our biology. Remember the clock gene, cryptochrome? Its name means hidden color. Recent discoveries have revealed that in addition to being sensitive to light, the cryptochrome protein may also be sensitive to magnetic fields. A theory known as the radical pair mechanism proposes that when a cryptochrome molecule is struck by blue light, it can create a pair of entangled molecules. The Earth's magnetic field could subtly influence how these molecules behave, which in turn might alter a neural signal. In essence, it is theorized that we might sense magnetic fields unconsciously, as faint modulations in our visual field. This remains a hypothesis, but it suggests that the daily wobble of the geomagnetic field could be another subtle time giver, another quiet whisper helping the SCN keep time. Finally, there is the most direct connection of all. The very atoms that make up the body, the calcium in your bones, the iron in your blood, the carbon that forms the backbone of DNA. Every one of these heavier elements was forged in the heart of a star that lived and died billions of years ago. The universe is not something external to you. You are a collection of repurposed cosmic material, animated with consciousness, and organized by rhythms gifted to you by the planet and the sun. Sleep, the nightly synchronization. We have established that we are built from the materials of the cosmos and timed by its rhythms. Now, let us return to the act of sleep. It is often regarded as a period of inactivity. The body is resting, the mind is offline. This is not entirely accurate. Sleep is an active and complex process. It is the time when the body performs a great nightly synchronization. While the SCN acts as the master clock, it is not the only clock. Nearly every cell, tissue, and organ has its own local clock. The liver has a clock that governs metabolism. The gut has a clock that times digestion. Even the star-shaped support cells in the brain, known as astrocytes, have their own circadian clocks that play a critical role in reinforcing the brain's timekeeping network. During the day, these numerous peripheral clocks can become slightly out of sync with each other and with the master clock. The timing of meals signals the clocks in the liver and gut. The timing of exercise signals the clocks in the muscles. Stress and artificial light all send competing time cues throughout the body. By the end of the day, the coherence of the system can begin to fray. This is where sleep performs its most profound function. Sleep is the moment when most external, conflicting time givers fade away. In the quiet and the dark, the SCN signal becomes the primary rhythm broadcast throughout the body. During the stages of sleep, the brain and body engage in a system-wide recalibration. Hormonal signals realign the molecular clocks in the liver, kidneys, heart, and brain. The slight desynchronization that accumulated during the day is corrected. All the individual cellular clocks are brought back into harmony with the master clock and, by extension, with the 24-hour rotation of the planet. Sleep is the act of retuning the inner universe to the outer universe. The consequences of failing to perform this nightly synchronization are significant. Chronic circadian disruption, the kind experienced by those with irregular sleep patterns, can lead to a breakdown in biological function. Studies have shown that chronic misalignment increases the risk for metabolic disorders, cardiovascular disease, and impairs immune function. Our biology is not designed to work against the planet, it is designed to work with it. The health of the body is fundamentally linked to maintaining this connection. The grand pattern, from cells to galaxies. Let us zoom out one last time and observe the larger pattern. The universe appears to favor rhythms, cycles, and oscillations. It builds complexity through a principle known as coupled oscillation, the tendency of independent rhythmic objects to synchronize when they are near one another. We see this in nature. A field of fireflies begins with thousands of individuals blinking at random. Slowly, they fall into sync, until the entire field pulses as one. The pacemaker cells in the heart each have their own internal rhythm, but because they are coupled together, they synchronize to produce a single, coherent heartbeat. Now, apply this principle to what we have learned. At the molecular level, clock genes oscillate in a 24-hour loop inside a single cell. That cell is coupled to its neighbors. The cells in the SCN are all coupled, creating a unified master clock. The SCN, in turn, is coupled to the peripheral clocks in the organs, synchronizing them during sleep. Your entire biological system is a network of coupled oscillators, which is itself coupled to the larger rhythms of the planet, primarily the 24-hour cycle of light and dark. This pattern does not stop there. Our planet, with its synchronized biology, is just one oscillator in a larger system. Its daily spin and yearly orbit are part of a predictable rhythm. The Earth is coupled to the gravitational pull of the Sun and the Moon. The solar system orbits the center of the Milky Way galaxy roughly every 225 million years. Our galaxy is part of a local group of galaxies, all gravitationally bound. And this local group is part of the Virgo supercluster, a massive collection of galaxies all flowing toward a gravitational anomaly known as the Great Attractor. From the feedback loop of a single protein to the gravitational movement of galactic superclusters, the universe is patterns within patterns, rhythms within rhythms. The feeling of insignificance comes from seeing oneself as separate. The biological reality is that you are not separate. You are woven into the fabric of the cosmos. Your sleep is not a disconnection from the world, it is your most profound connection to it. It is the moment you return to the ancient, planetary rhythm that has guided life for billions of years. We began with a feeling of being a small, solitary observer in a vast universe. We have traveled through billions of years of evolution, deep into the cell, and out to the scale of galaxies. We arrive at a different understanding. The feeling of being a small part of a large pattern is not something to be feared. It is a reality to be observed. You are a complex harmony of countless smaller rhythms, all nested within and synchronized to the rhythm of the universe itself. The starlight that feels distant is made of the same elements that form your bones. The silent rotation of the Earth is the metronome your body has followed since the beginning of life. So tonight, when you lie down to sleep, you might see it differently. It is not a shutdown. It is a synchronization. As the world fades away, you can feel the connection, as the body lets go of the noise of the day and attunes itself once more to the deep, steady pulse of the planet. You are not just a speck floating in the cosmos. You are a note in the cosmic symphony. And through the simple, nightly act of sleep, you are playing your part. If this perspective has offered you a new way to look at your place in the universe, please share this video with someone you think might find it meaningful. For more explorations that connect the personal to the cosmic, make sure you are subscribed to the channel. Thank you for watching.